and all the people present here. Welcome you all to this great morning of the workshop, which is a 2-day workshop. And I just would like to make a very small mention about what BAJA's journey has been, beginning from, SAE India having over 5,000 professionals. We have about 40,000 students and 495 collegiate club. We have various events for the students, beginning from, of course, BAJA, which is the largest. And we have Supra, we have Aerathon, we have Tiffon, we have World in Motion, and so on. And to talk specifically about this great story of BAJA, beginning from 2007, when we had just 27 teams, this event has grown and grown and grown into one of the country's leading platforms for engineering students to hone their skills. And we are very proud that a lot of students who have gone through this event have set their foot globally, not only in India, but in the automobile space in various countries. So that speaks volume about this event, the kind of return the event has on the participation of students. We also have, an HR meet, which helps them to, participate in the HR rounds where they have an opportunity to be interviewed by various automobile and ancillary industries to find them employment opportunity also. So this is what it is all about, BAJA. We started off with just hBAJA in 2007, and then sometime in 2015, under the guidance of late President Dr. APJ Abdul Kalam, we started the E chapter. And in 2024, we started the hCNG chapter, along with the autonomous BAJA chapter. The entire process of BAJA has been keeping in pace with the country's requirement of Make in India, Viksit Bharat, and all the initiatives that the government has been declaring from time to time. And we're very, very happy that the event has stood its test of time and has garnered so many young engineers into better automotive professionals, and it has helped the country's economy in a very large manner. So that is what I would like to talk to you about the event in specific. And this is where we can talk about our growth story beginning from 2006. The first event was in 2007. Then in 2010 we started off the HR meet with an aptitude test. 2015, we started the hBAJA, the E chapter. 2018, we expanded from one location to 2 locations because we could not accommodate all the students in one location. We had a second event in the north, the first event being in Indore. In 2021, we started the virtual BAJA during the COVID time. We did not look back and we did not stop the event even during the BAJA. Even during the COVID, we had the virtual BAJA. And then in 2023, we started the hCNG chapter and the A.
Using Baha's major events and extensive industry expertise, we are honored to have her with us today. Over to you, ma'am.
Thank you so much, Sandeep, for the introduction. So, first of all, I would like to thank Balraj sir. While you were speaking, we were driven into the memory lane, which started from the 2006. So, how the years has passed, it's truly a wonderful and marvelous journey for all of us. So, now let's take a look at how hBAJA event has evolved over the last 3 years. Next slide, please. Sandeep, next slide, please. Yeah. So now take a quick look at how hBAJA has evolved. The hBAJA category was officially launched in 2023, marking a significant milestone in BAJA SA India's legacy. hBAJA is one of the newest, yet the most forward-looking category under BAJA SA India. In 2024, we hosted the first ever hBAJA event at Natrax, Pritampur, showcasing a CNG-based engine. And now for 2026, we have a challenge for the engineering students to develop and demonstrate the hCNG with 18% hydrogen, and gradually we will be going towards a fully hydrogen engine BAJA buggy. So all the hBAJA vehicle must be mandatorily the mBAJA vehicles and not the eBAJA based EV. Vehicle can be two-wheel drive, four-wheel drive or all-wheel drive. The technical goal of the competition is to develop the IC engine vehicles with 0 to 100% hydrogen transition gradually with an aim towards safety and sustainability with zero carbon emission. The participating teams will be expected to convert the biofuel gasoline CNG powered SI engines into the biofuel gasoline hCNG powered SI engine. So the proposed event will have a similar event that of the mBAJA, which will include the virtual round and the statistics and physical dynamic events. Next slide, please. Yeah. So the first hBAJA event was held in 2025 at Natrax, Pritampur, a crucial milestone which was inaugurated by Honorable Shri Nitin Gadkari ji, Minister of Road Transport and Highways of India. So also I would like to inform you all that he have a hydrogen powered Toyota car which is named as Mirai, which means future in Japanese. So first of its own kind of car in the world. So Gadkari ji during the inauguration also mentioned that the attention towards hydrogen fuel is in alignment with our national hydrogen mission, which aims to focus on green and clean energy. So he assured that India will manufacture green hydrogen and establish refueling station, which would create employment opportunities in the sustainable energy sector in the country in near future. So this shows how BAJA SA India emphasizes and always try to develop the participating students to be future ready and ahead of current times by providing a cutting edge knowledge and practical experience to their students. So here are the few glimpses of last year's event at Natrax. You can go through that. The pictures you can see is how Nitin sir has inaugurated along with our organizing committee members the hCNG vehicles and how the overall event was carried away. So next slide, please. So now let's move towards the performance. So here are the few performance highlights from the past hBAJA events. So talking about the vehicle weight, with the average weight of 300 kg with the lightest vehicle at 268 kgs. Talking about the endurance statistics, the vehicle has completed approximately 40 kilometers on average and around 25 laps completed per team. Talking about the acceleration statistics, the best 0 to 50 kilometers per hour in 7.460 second and average and minimum about 7.460 seconds. So looking towards the history of hBAJA teams participation. So in 2024, we had 3 teams. Then we grew to 18 team, and then in 2026 we have around 23 teams registered, and we are planning to double this number in next year. So this surge reflects how strong the industry backing and the growing interest in the hydrogen mobility. Also, this stats demonstrate that how students are pushing for the vehicle performance even with the newer and alternative fuel technologies. So also we also take pride in our industry partnership with Advantage, Greaves and Atul Auto, who plays a crucial role in mentoring these teams and validating the solution. So, with this, I would like to extend my heartfelt thank you to all the students who have joined us for this 2 days workshop. A special note of appreciation to the organizing committee members for their continued support and guidance, and the alumni committee members for their dedicated efforts which goes behind the scenes. So we are also immensely grateful to our all industry partners and the sponsors whose support plays a crucial role while driving this event. So wishing each one of you a rewarding and inspiring learning journey ahead. So keep learning, keep innovating, and keep rising your ideas. Thank you once again. Wish you all the best.
Thank you, ma'am, for your words. It's an honor to welcome Dr. Casey Ora. It's an honor to welcome Dr. Casey Ora, advisor of BAJA SAEINDIA and highly respected expert in automobile research and former senior deputy director at ARAI. With decades of experience in mobility innovations, engineering education, and policymaking, Dr. Ora has been guiding force in shaping India's automotive future. We are privileged to have him with us today. Thank you, sir. Over to you, sir.
Thank you, Sandeep. Good morning, everyone. Uh, it gives me a very warm feeling today addressing all of you. As Balraj said, we started BAJA event in 2007, and then in 2015 we went into hBAJA. And 2024 we did the first CNG event, and then 2025 the hCNG event with 5% hydrogen, and 2026 we are looking forward to the hCNG event with 18% hydrogen. And I must also acknowledge Mr. Nitin Gadkari, our transport minister. It's all because of him. I remember that day, 9th January 2025, at Netrex ground in Pithampur. He gave so much of encouragement to all of us that I am sure that from 5% to 18%, 18% to 50%, and then 100% is what is our target. And we will move towards it as the automotive industry moves towards it. Today, we are not allowed to use 100% hydrogen in India because we will require so many safety precautions to be taken. So it's better that we do it gradually. But the aim is that our young engineering students must learn this technology. And when they learn this technology, they will be useful in the future automotive industry where we will be working on 100% hydrogen. So looking at two aspects, one is electric mobility, another is hydrogen mobility. Both are equally important for the country when our Prime Minister Sri Narendra Modi ji has declared that in 2047, we will be energy independent. That means no fuel would be imported, nothing will be imported from outside. We will manage within the India. And by 2070, it will become net zero. That means carbon dioxide net will be zero. If we have to meet all these targets and become Atmanirbhar, we want these young engineering students to be industry ready. They can become a good startup or they can join industry and component industry to lead. And that is what we dream and we wish that it would happen. So today and tomorrow we have this wonderful hCNG workshop or hBAJA workshop, where we have many stalwarts here who would be giving presentation and spreading their wisdom. The most important person today is Mr. Yogesh Agav from Kirloskar Oil Engine. He and his company himself has already got the type approval of hCNG with 18% hydrogen from ARAI recently. And I think that is one of the best thing to listen from him, that what is this technology, how are we going to move forward in this arena, and how hydrogen and fuel cell will become very important. I must also tell you that we got this idea of hBAJA when MNRE released Green Hydrogen Mobility Mission Plan in January 2023. So in January 2023, when this mission plan was released, I had a chance to go through the entire document, and we can see that how our Indian government, Niti Aayog, and various ministries like MNRE, Ministry of Transport, Ministry of Heavy Industry are all working towards making India Atmanirbhar and also making India net zero. So this is the story of Vikasit Bharat, and you all engineering students who are here in this workshop, you are the one torch bearers who are going to take this forward. So besides besides Yogesh Agav, we have the director of Netrex, Dr. Manish Jaiswal, who will be speaking tomorrow in this event. Then we have Mr. Ranjan Nair from Bharat Petroleum, who would talk about various fuels which would be required to be developed. Then we have Dr. Syed Kalimuddin, the R&D head of GREAVES in Aurangabad, and he himself has done series of experiments with 18% hCNG on the GREAVES engine, and that too on a new GREAVES engine. It has, compared to last year, this year we have a better engine with aluminium, more parts of aluminium, and I'm sure that this will improve the efficiency, this will reduce the overall emission, and also improve the durability of the engine. So as GREAVES moves forward to help us to develop better engines for hCNG, we are very fortunate to use GREAVES' latest engine, that too fuel injected, for this application. So we will listen from Dr. Kalimuddin also. Then we have with us Dr. Rajesh Kumtekar from Fluid Control. He is going to talk about what are the rules and regulations. And then we have Mr. Rajiv Gaiki from Advantex, who is Advantex is one of the leader in providing fuel injection system for CNG, hCNG, and hydrogen, and they are working closely on various aspects of alternate fuels when those needs to be used in engine. Then we have Makarand Lad. Makarand Lad was earlier in Volvo, and now he has joined a company called, what is it called? Rameshwar, what is the name of the company of Makarand Lad?
Time Technoplus.
Time Technoplus. Yeah. So he is in Time Technoplus. And then we have Dr. Ajit Babu. Ajit Babu is from Good Life Mobility, a startup producing hydrogen cylinder at Madurai. And he was earlier in ARI. Then we have with us, we are left with two speakers. So one is Saurabh Suman. Saurabh Suman have extensively worked on alternate fuel at Mahindra & Mahindra, MRV, Chennai. And he is the one who is leading this entire hBAJA activities with the help of organizing committee members and the alumni committee members. And who is left now, Rameshwar? We are done?
Sir, Piyush Balia and Ranjan Nair, sir.
Yeah. So I talked about Ranjan Nair, and yes, we have Piyush Pai, who is from Atul Auto near Ahmedabad, and he is an expert in entire vehicle engineering. That means how do you put an engine and the fuel system and the intake system, exhaust system, cooling system is all what Atul Auto does when they use GREAVES engine on their vehicle. So I'm very happy to note that we have all special speakers for this 2-day workshop, especially for the budding engineers to learn how to make and how to optimize an hBAJA vehicle. And I wish you all the best to gain this knowledge and become perfect in making your hBAJA buggy. And then we meet during the final day when you come with this hBAJA buggy and run with 18% hydrogen hCNG in your vehicle. So wish you all the best for the workshop and for the hBAJA event. Thank you very much.
Thank you, sir, for your valuable insights. For the vote of thanks, I would like to call Mr. Joel Joe Thomas, currently leading BAJA SA Alumni Committee and currently working as Advanced Structures India, and also recognizes the Best Alumni Committee member at BAJA SA India 2025. We are honored to have him here today. Over to you, sir.
Yeah, hello. Hope I'm audible. Good morning.
Yes.
Yes,
Thanks
sir.
for the introduction. So my job is to just thank everyone. So first and foremost, I would like to thank everyone who is here today and this morning, and especially all the speakers who have taken time from their holiday to share their insights with all these budding engineers here, and also to all the organizing committee members as well as the alumni committee members who are present here. Thank you for making this happen. And to all the speakers, thank you for sharing. Thank you for agreeing to do this. And to all my participants, all my student friends, all the best. Learn whatever you can in the 2 days. Ask more questions. Don't be afraid to ask questions. Ask more questions rather than sitting and listening more, so that you understand more at the end of both the days. And yeah, that's it. All the best. And thank you everyone for making this happen. And yeah, thanks.
Thank you, sir. Uh, Now let's quickly start into our workshop topics. So the first topic is basics of hCNG technology and vehicle adaptability. So this is from Dr. Yogesh Aga. So it's my pleasure to welcome Dr. Yogesh Aga, Vice President, Head Advanced Technologies and Research at Kirloskar Oil Engines Limited. With an over 19 years of experience in engine design, combustion science, and sustainable fuel technologies, holding a PhD from IIT Delhi and advanced degree from IIT Madras and VIT Pune. His leadership is alternative fuels, IC engine innovations, and mobility research has shaped India's automotive future. We are honored to have him here today. Thank you, sir. Over to you.
Thank you. Good morning to all, and it is my privilege that I got invitation from ACE to give some presentation. So basically, we at Kirloskar Colleges not only just develop technology for sake of technology, but we develop it into complete product. And that is where this is very important, that we need to do certain changes and etc. So I will take you through that journey. As Dr. Vora sir said, that we got the first hCNG type approval from ARI. That means it has completed all the regulatory requirement, emission requirements, everything. So that is the first. Though it is for genset application, but the technology also is applicable for all other application also, because engine is engine, and engine material, combustion system, everything remains common. So let me share my presentation. Uh, 1 second. Can you see my presentation?
Yes, sir.
Yes, we can see.
Yeah. So basically, I will talk on hCNG technology or hPNG technology. So why I'm saying PNG or CNG? Because CNG is applicable for vehicles, whereas PNG is applicable for pipeline gas. So where blending can be done, and BPCL and all other people can talk more on blending, but I will talk on more on engine and engine modifications and how to approach this technology. Okay. So now purpose of my presentation is competition workshop. So giving guidelines for students who are working on who are participating in hBAJA competition. Objective is elaborate hCNG technology, and basically when we talk about hCNG technology, so we have to see learn about hydrogen and as a fuel. So these topics will be covered during my presentation. Duration will be around 30 minutes, and then followed by some questions I will take. Okay, so green hydrogen as a clean fuel. So need of alternate fuel. So what are the needs? Why alternate fuels we are talking about? Because fossil fuels have a problem. Though they are available, availability is also issue for long term, but they also result into environmental pollution. So how to address this environmental pollution? See, for example, in Delhi, they say that around 50% is automotive pollution. So transportation pollution is at 50%. So this is like dense cities. In India, there are so many metro cities, dense cities are there, and environmental pollution has become a problem. Then rising cost of conventional fuels is also important, and then geopolitical issues are also making it more difficult to have a consistency in the cost. Then in country like India, where we 80-90% we import fuel, so we are now dependent on imported fuel. So how to cut down this? And fuel reserves are depleting fast. So can we also develop industry in rural area? So good example is ethanol, so which is a byproduct of sugarcane industry, and this can be give boon to farmers, agro industry. So these are the some topics. Now converting, when we convert a particular engine for alternate fuel, so what we have to see, we have to study is a combustion system, which consists of combustion chamber and ignition system, then fuel handling system. So how to do fuel pressure regulation and air fuel mixing, then control system, air fuel ratio control and quantity control. So this control system also needs to be developed, and exhaust after treatment. So which kind of exhaust after treatment is necessary for a particular alternate fuel. So this all these studies to be done. And finally, lube oil. Lubricating oil is also important because it has to counter the combustion products. So this is also important. And material compatibility. So whatever fuel system you are going to use, that components should be compatible to the alternate fuel. And fuel distribution is of course a government related issue. Now if you see, the India signed COP26, and then India part to near net zero by 2070. So long term low carbon transition and development strategy rests on below 7 key transitions. So there are 7 transitions, and we in various things are there, right from forestry, vegetation, etc. But for us, important is to develop an integrated, efficient, and inclusive transport system. So that is important for mobility engineers, and development of carbon dioxide removal and related engineering solutions. So these are the important solutions which are necessary. So this is how we need to develop our own solution for meeting COP26 targets. So India is going to transition in that manner. Now, how does hydrogen is a very key important in achieving this role of net zero. So what are the important properties of hydrogen? So it is element number one. So simplest element on Earth, hydrogen. So this is very important. Abundancy. So 75% of mass in the universe is hydrogen. Detectability is a problem because it is odorless. Combustion is also invisible. So we need to address this from safety point of view. Volumetric efficiency, volumetric energy density is very low. So this also we need to address. We need to use high pressure system for high pressure storage system for hydrogen. Natural state, so rarely exist in free state. So this is very important. So we need some techniques to generate hydrogen. Weight, it is very light. So this is good from point of view of safety. Immediately diffuses in air, and gravimetric energy condensity is the highest. So this is very important. So almost 3 times it has the its calorific value is almost 3 times. We will come to that. So so hydrogen as a fuel, when we talk of IC engine fuel, so some properties we have to really consider while designing a hydrogen engine. So, so I have given a table of comparative properties of hydrogen, CNG, gasoline, and diesel. But important properties are carbon content is zero. So decarbonization, this really helps decarbonization. So what we say carbon zero fuel, very high calorific value. So it is almost, I told you, told all the people that it is almost 3 times. Then high auto ignition temperature. So this necessitate spark ignition. So compression ignition is very difficult. Then higher laminar flame speed. So this is very important property. So actually speed of engine, maximum speed of engine is dependent on combustion rate and laminar flame speed. So with hydrogen, it is possible to achieve higher engine speeds than whatever we are employing now. High diffusivity, as I said, disperses quickly and very low density. So it requires high storage volume, high pressure storage requirement. Now, if we look at the basics of combustion, so when we burn hydrocarbon, so it results into CO2, CO, HC, NOx emissions. But hydrogen is, if we burn, it results into water vapor. But some NOx is generated, so because they are available in atmospheric air, so they go into combustion chamber and form NOx emissions due to high temperature and high pressure conditions. But how to address this? So this is a very important challenge for hydrogen engines. For hydrogen engines, challenge is only NOx emissions. So the hydrogen, so if you see hydrogen, it can be produced from various sources, and depending on the sources, it is called as green hydrogen or blue hydrogen, all things. So this is briefly again, important is flammability limit is also very high. So this is important that lean operation, very lean operation or rich operations are also possible with hydrogen. Then very high octane number. So this is also important. So compression ratios can be increased to get better fuel efficiency. So as I said that these various hydrogens are available, and people are working on that. Oil companies, refineries, everybody is working on that. We are also actually, in fact, in Kirloskar Challenges, we are also working on how to produce green hydrogen. So basically, green hydrogen is the hydrogen which is produced from by electrolysis and using renewable energy source. So that is a green hydrogen. Now this shows that the energy content and then storage requirement. And so if you see compressed natural gas is very low in very high energy content, but very high pressure have to be used. So it will requires compression 700 bar we talk nowadays to store the hydrogen. Now, if we develop completely hydrogen engine, so this is the engine system. So we need to employ. So ignition coils should be low energy to avoid backfire. Spark plug preferred is cold rated spark plug. Wall train optimized wall timing to avoid backfire. Wall seat design for leak proofing and also high temperatures. Turbocharging. So turbocharging is required, and as hydrogen requires more air, so we need to achieve higher airflow. Then fuel system, special materials used, leak-proof joints are there in fuel system. Then hydrogen close crankcase ventilation system is necessary to avoid leakage of hydrogen in the atmosphere from low-by gases. Then leak detection system is also necessary, and lube oil, of course, needs development for avoiding the water contamination. So now, what are the technologies to reduce NOx emissions? So now this slide shows effect of lean combustion. So as we said that flammability limits are very high, we can go to leaner side, and if we go to leaner side to around 2.2 air lambda, so NOx becomes almost zero. So generally hydrogen nowadays hydrogen engines which are dedicated hydrogen engines, they are lean burn combustion, so that there is no critical after treatment devices are required for cutting down NOx emissions. NOx emissions also can be addressed through in-cylinder combustion. So this is again how heat release. So if you see the stoichiometric combustion, then there is a blast. But if you do lean burn, so slow combustion rate is there. And then the brake thermal efficiency also is good for hydrogen, because once the air excess ratio improves, pumping losses go down and brake thermal efficiency improves. So it goes to 34, 35. So very good efficiency you can get by lean mixture. So now various injection systems are employed in hydrogen. So that is manifold multi-point injection or direct injection. So both are possible, and both have their advantages and disadvantages. But initial engines are a manifold injection, and now direct injection is under development. So this we at Kirlos College we have done work on 100% dedicated hydrogen engine with IIT Delhi under MNRE, and we also developed oil for this, and we got a patent for this. So for a genset application. However, hydrogen will take some more time. See, hydrogen requires a lot of changes to be done. So what are the other avenues which can reduce emissions? So therefore, this blending technology was developed to mix some percentage of hydrogen into CNG, and that is what it's called as hCNG. So now this slide shows the work which we have carried out. So with 18% hydrogen mixed in 82% methane, and we could get very good results. So CPCB2 emissions directly improved to CPCB4 with some minor changes in cylinder pressure. So this is the very important achievement we could show while doing this project. So this was the engine which is completely instrumented, and it has also CATCON, all the fuel system, everything. And we actually did studies with different blends, 18%, 25%, 30%. What we found that 18% up to 18%, 20%, 18 to 20%, it is giving benefit. Above that, it becomes a stoichiometric hydrogen engine. So stoichiometric hydrogen engines are having some issues. So like emissions are a bit higher, and then it was behaving like hydrogen engine. So we limited to 18%, and government of India is also going to limit the hydrogen for hCNG to 18%. So, so brake specific fuel consumption, you see that with hCNG it improves. So less fuel efficient, less fuel requirement is there with hCNG, and then this is very important factor AFR, so air to fuel ratio. So with hCNG, air to fuel ratio requirement is higher. So higher air is required. So therefore, whenever you are doing calibration, you need to take care of both these things, that fuel flow reduces and air flow, air to fuel ratio increases. So we have to do these changes to achieve optimum performance. So this I talked already that 18% hCNG blend showed 61% improvement in CO, 85% in non-methane hydrocarbon, and 53% in NOx emissions. So this is very good fuel to which can address the ambient air quality, air pollution levels. Now another factor is the materials, because once you introduce hydrogen into fuel, so we have to see that how this material has to be selected. So non-metallic, so wherever you use nitrile rubber, it will not work. We have to go with whiten rubber. Then other metals, mainly we have to use stainless steel material for fuel system. So this is very important to achieve the material compatibility. So this is just guidelines for the students while they select materials for fuel system. Thank you. So this is all. That's all from my short presentation. So
thank you, Dr. Yogesh Sagar, for such a nice presentation. We understood the technicality of how to develop an hCNG engine. I have a couple of questions.
yeah.
When we are shifting from 5% hydrogen to 18% hydrogen in our BAJA buggy, we want to know what are the precautions to be taken. Is there any chance of fire, or do we need to use any fire arrestor in the intake or exhaust system, or 18% is very safe, we don't have to worry? Just throw some light on that.
So in my opinion, 18% is safe. We don't have to worry that much about this. But components, as I mentioned, that rubber components and other components have to be properly selected. Stainless steel material to be selected for a fuel system, because see this leakage and leakage related issues are there when you have hydrogen in the fuel. So this can be, but there are less chances of backfire or what we say pre-ignition or something like that. So that is very important. And we have to do also some calibration changes in the software, which of course calibration engineers can do to take care of higher airflow requirement and lower fuel consumption.
Okay, thank you. And what should be the increase in when we shift from say CNG to 18% hCNG? How much percentage of compression ratio can be increased?
Well, how much percentage of
compression ratio can be increased?
The compression ratio we have not changed, because see we can change, but we limited it, because in case hCNG is not available, people should be able to run with CNG. So we have not worked on compression ratio, but it can be, I can work out and give you a one-to-one message, send you some calculation, theoretical calculation, and we can run the simulation without knocking. We can definitely increase the compression ratio. So I will ask my engineers to do simulation and share some slide with you.
Thank you. Thank you very much, sir. Thank you. Any other questions? Anybody else wants to ask any question?
Teams, if you have any questions, please put in chat box. We will read it and ask Yogesh sir.
Question is that why there is a need to change 5% of hydrogen to 18% of hydrogen?
See, hydrogen is ultimately the direction is that we have to go with hydrogen because to cut down the emissions and make it sustainable. So hydrogen is the fuel where emissions are taken care. So this is the idea. But directly moving to hydrogen, complete hydrogen will take some time because all distributed network, then hydrogen generations, they have multiple issues. But start point could be 5%, 18%, up to 18% hydrogen, which gives good benefit with environmental benefits and also improvements for the end users. So this is my submission. Yeah.
Thank you. Any other questions in the chat box, Rameshwar?
Yes, sir. There is a question for material where we can source it.
Material?
Yes, sir.
Material is available with fuel system suppliers, so those who prepare gas trains or cylinders or hoses. If you contact them, this material will be available from those people who prepare these hoses and tanks, fuel tanks, and all these things.
Is there any change required in the injector from CNG to hCNG?
Definitely, we have to use Viton O-rings in the injector, and also material compatibility also we have to see.
Okay.
But not much. Already, I think manufacturers have that compatibility of material. Only O-ring we have to see wherever sealing is there.
Yeah, so we are getting it from Advantech, so I'm sure that they would have done all that.
I'm sure that they must have taken care of
yes,
that.
Yes.
Sir, if we are already using this cotton G400 WT.
Can you repeat? I could not hear you.
Then for shifting from 5% to 18%, any engine there is need or?
Your voice is not audible. Otherwise, can you put the question in the chat box?
Question is that
if you have any questions,
shifting from 5% of hydrogen to 18% of hydrogen requires any changes in engine or our transmission?
Yeah, some calibration changes will be required. Minor calibration changes will be required, and minor. But the fuel system supplier will take care of those. So whenever you are doing calibration, so that will be taken care. So definitely required. Yeah.
Thank you.
Okay, Rameshwar, if there are no more questions, can I log off now?
1 minute, sir. I will ask one more time. Team, if you have any questions, please put that in chat box, or you can unmute yourself and ask the questions.
Okay, I think we will, in case there are more questions, we will send it to Dr. Raghav. And thank you very much, Dr. Raghav, for coming here and gracing and becoming the first keynote speaker of this session. Thank you very much.
Thank you, Vora sir, for inviting me. It is my privilege to share whatever we are doing on alternate fuels.
Thank you. Thank you very much.
Thank you.
Thank you, sir.
Yes. Sandeep, just 1 minute. Kalim sir is joining.
Okay.
Anybody else till the next speaker join? If anybody have any questions, please feel free to ask. You can put up the questions in the chat box. Or if somebody wants, you can take a bio break for a couple of minutes till the next speaker joins us.
Vora sir, there is a question.
Yes, Kalim sir is joined. Good morning, Kalim sir.
Hello, Dr. Kalimuddin. Good morning.
Morning, sir. Good morning, everybody.
Good morning.
Good morning.
So we will start with the introduction of the speaker. Sandeep, please go ahead.
Sure, sir. Good morning. It's a pleasure to welcome Dr. Kalimuddin Syed, General Manager at Greece Cotton. With his vast experience of 26 years and leadership in industry, we're truly honored to have him here today. Let's give him a warm welcome. Over to you, sir.
Yeah, good morning, everybody. Thank you for my introduction. I'm sorry, actually, I'm traveling, so there may be some disturbance in presentation, and I was delayed for the joining. Okay, but I'll try to take up maximum explanations so that team can able to get full knowledge about the product. Just 1 minute, huh? I'll just settle myself.
Yeah, sure.
Okay.
Yeah, friends, actually, welcome to hBAJA again. It's a opportunity to be with you. And again, I think we'll excel. Previously, we have already there for hBAJA demonstration with 5% hCNG. Now, now we are anticipating to go with 18% hydrogen with CNG fuel. Already we have tested the engine's performance with 18% hCNG at our testing agency. That is at Technology Center Greaves. And results are encouraging. There is no much adverse effect of the hydrogen on the equipment or on the engine or on the performance of the engine. As far as safety concerns are there, we will adhere to the safety concerns as per the regulations what has been given to us. And I'm sure that this time also we'll demonstrate hBAJA buggies with 18% hydrogen in CNG fuel. So I think Rameshwar, you can go to next slide. So we are going to offer you 400 cc. We call it actually the cubic capacity is 395, but we round off to 400 cc. And it is a water-cooled engine, which we are giving for three-wheeler applications to different OEMs for across India. And this engine is proven engine. It has run more than lakhs of kilometers. Almost 8 lakhs of kilometers has been covered on three-wheelers vehicle. And as such, doesn't have any adverse effect or failures of the engine. Maybe 1 or 2 mechanical failures are there, but it is related to the application point of view, how it has been applied on the vehicle or on any other application where we are going to use this engine. So same engine we have offered for hBAJA students. And we are there to support you for all the activities related to the powertrain. Do not hesitate to contact us anytime. Myself and my colleague, Mr. Suresh Sajjan, he will also be there to support you along with my team. I think Suresh is there today. Suresh, can you confirm you are there today? Because he was also busy. I was also busy. I was traveling with some other assignments, but I assigned Suresh also. I think he may join if he is not there. So rest assured that you will get all the supports towards the powertrain. Please feel free to contact us for any issues are there related to the engine. These are the contents of my presentation. You can see we'll just talk about hCNG as the futuristic full IC engines. Then we'll talk about engine specification. Then we'll talk about engine performance, its nomenclature, what are the sensors used on it, what are its layout, how the lubrication system of the engine works, how is the cooling system of the engine works, what is OMS system, that is for oil mist separators. It is a short form of it. So this is mainly used to arrest the crankcase vapors and to condense it and again recirculate in the crankcase. Then engine charging system, which is necessary for your buggy electrical system requirement. Then what is the exhaust system we are going to use it. Then what is the engine CNG layout on the buggy or on the vehicle. Then gasoline engine system. This is actually we use as a lymphome application for three-wheeler. And I anticipate for buggy also when you are building the buggies, you can use as a gasoline to start your buggy and see the system is working properly, engine is working properly, water system is working, water circulation system is working properly. That you can do on gasoline because it is available and it can be user-friendly fuel, we can able to say. But some safety precaution has to be taken in the college when you're using gasoline because it is flammable also. Then what is the engine layout and its accessories we'll talk about. Then basics like tightening torque, what you have to follow. The chart we have given to you, you just follow. Also, we have shared workshop manuals to hBAJA team, technical team. You can take that workshop manual from the team and the service schedules, what is required. I think service schedule may not be much useful for you, but since if suppose you want to run kilometers or you want to go for endurance, just visit the service schedules, what has been given for the engine in the workshop manual. Next slide, please. Yeah. Coming to hydrogen enriched compressed natural gas, we call it as a futuristic fuel because the advantages in the greenhouse gases, what we are getting with the hCNG. And it is proven actually, we have recorded the performance and we are getting a good improvement in CO and hydrocarbons. Of course, there is some increment in high NOx emissions. That also we are trying to optimize it with the help of say some EGR systems and other things. But now for buggy, emission legislation is not there, so relax about it. Then hydrogen resources are vast. It is considered one of the most promising fuel for automotive sector. And hydrogen has been regarded as a future secondary fuel. And I anticipate that this will be a future secondary fuel with CNG. Then anticipate the addition of hydrogen into natural gas. Gas increases the burning velocity. This we have seen in our we can say, combustion behavior of the engine. We recorded some combustion pressures and other things, and we found that it is really helping us for early burning and a short duration of combustions in the cylinder and increasing the slight temperature, exhaust temperature, but it is for a momentary. And it also increases thermal efficiency. Of course, when increase the improvement of the engine performance, thermal efficiency automatically get increases with almost lean mixtures, you can say. Thing is that hCNG works, our CNG works with a lambda as a one, as a unity. But we are observing that hCNG is supporting to go for lambda almost 1.2. Till 1.2, we can explore lean lambda. And that is the reason CO and HCs are low and NOx is somewhat higher. So there is a scope for us to improve it further. Then hCNG engine increases H/C ratio of the fuel also, where the carbon content is less here as compared to hydrogen. Drastically reduce carbon-based emissions such as CO, CO2, and SC. Then to increase the flame speed of hCNG engines, the ignition timing needs to be retarded. Of course, yes, this results in NOx reductions, but it is also having an adverse effect of high exhaust temperatures. But since engine is water-cooled engine, so fear of high exhaust temperature is not much. But however, looking to the aluminum as a material, aluminum alloy as a material in cylinder head and barrel, we are cutting off the maximum temperature to 700 degrees centigrade at full WOT with wide open throttle conditions. But on buggy or on the vehicle, you won't observe this temperature, or you cannot record this temperature because it is momentarily for a higher RPM, higher load conditions. So that is not possible on a vehicle to get that much speed of the vehicle, and of course that much load is not possible at that RPM. So that exhaust temperature may not reach on your buggies. Then it is important to note that 18% blend of hydrogen by volume with CNG, the phenomena of hydrogen embrittlement doesn't occur. This also we have done it. We have done a study on the components. Of course, aluminum is non-ferrous, so corrosion and pitting is not much anticipated there. But we are using a sleeve as a barrel in the barrel. So we have assessed its metallurgical condition. So we won't find any hydrogen embrittlement or cracks on the barrel size. Of course, we have to run durability and endurance for it. We have run for a limited hours of 100 hours or 200 hours like that. So that could be the reason. And so for the buggy, I think need not to fear about it. Go to the next slide, I think. These are the comparison properties. It is a textbook values. So you can go through the flame velocities. Actually, that is important here. Burning velocities is much higher as compared to our methane, that is 45. So that is an advantage we are getting for the better combustion for this engine. And auto ignition temperatures are almost similar or somewhat better in hCNG as compared to CNG fuel. Equivalence ratio, of course, we are working with 0.5 to 0.54, which is too lean. And it is coming to a theoretical value, actually. Theoretical value says it around 6, but we are coming to 5.4. So it is coming below that. That is an advantage for us. Yeah. Go to next slide now. Now, these are the few advantages, disadvantages of hCNG. It is usable with existing infrastructure. So just to inform you that we have used the same infrastructure what we are using for CNG. Same type 1 cylinders we have used for hCNG. Of course, regulations and approvals, we have taken it to fill it. And government is allowing us to fill up to 18% hydrogen in CNG. So blending is being done. The process of blending in with hydrogen is a longer process. It takes almost 48 hours to stabilize at our supplier. Not we can do. We have to do at our supplier end, where CNG gas we get from the supplier, say INX or some other suppliers are there. So they will mix it, they will blend it, and for the blending, they will take at least 48 hours to blend with hydrogen with CNG. Then they will fill this gas around 250 bar, and they will send this gas to us. Then we used to test it on our engine, and it is directly connected to our test cells. So my request to the students that when you are connecting this hCNG, the hCNG high pressure pipes, please ensure there should not be any leakage for the safety point of view. It requires only a small hydrogen storage and a column of a mixing of hydrogen that I already explained you. It extends the lean misfiring limit for CNG, that also I explained you. Then minor modifications are required in the engine due to moderate concentration of hydrogen. Yes, there is no change in the engine specification from CNG to hCNG. Only data set will change, and the rest of the hardware is same. So the team who has taken earlier engine, who has bought our earlier engine for CNG, same engine can be used for this application also. And last year also same engine was demonstrated with 5%. Now we can extend till 18%. So need not worry for that. Hydrogen embrittlement doesn't occur till 18%. That is an advantage. Then it improves the engine efficiency. That is also an advantage for us. Then Government of India has taken a decision up to 20% CNG blend as on par with CNG. So these are the advantage for us in future. And of course, being you're a student, you can explore your career in this domain where alternate fuel is growing nowadays. Some challenges are there. hCNG storage and supply infrastructure. Yes, all cannot supply this. Who are having a good infrastructure can only supply hCNG. Few suppliers are there in India. Ionex is one of the supplier who can able to supply. Then IOC is there, Indian Oil Corporation. They can also give this. Then effort to be focused on responding to fuel system performance, material compatibility. Yes, it needs some more focus to be done to adhere these points. Then emission testing with more range of hydrogen. So we need to explore more hydrogen in hCNG. Say today we are at 18%, tomorrow we'll be exploring 30, then 40. But of course, there will be certain modification on the engine side. Then safety sides also we have to look into. Continuous availability of hCNG need to be assured before embarking on its major use in IC engines. Yes. Then continued engine performance, emission and durability testing in a variety of engine types and size need to be developed to increase consumer and manufacturer confidence. Then development of less expensive quality test. Then this also have to be done to ensure that it is a safe fuel for the future. Move, Rameshwar, go to the next slide. Now coming to the product, what we are offering, it is a G400WG. Now for the BS6, there are two models, 395 and 400. So 400 was engine already given to you. Now we have just changed the nomenclature, being it's all aluminum engine. So we made it engine cubic capacity is same, specification remains same for both the engine. Only thing is that whatever the engine which has been procured earlier is having a cast iron barrel, total cast iron. But right now we have converted it into aluminum to reduce the weight. Some balancing we have done in the new engine, so to reduce the vibration point of view. So there is some improvement in the engine what we have given earlier. Engine specification remains same, bore and stroke remains same, cubic capacity remains same, rated power remains same, that is 7 kilowatt, maximum torque of 23 Newton meter. Dry weight is almost similar or somewhat lesser as compared to 46 in the new engine. Oil capacity remains same, 1.6 liters. Then including filter, we are having a spin-on filter there, so that takes almost 200 ml in it. Lubrication is forced. Then cooling system is pressurized water circulation system. There is a water pump in the engine. So when I am going to the different slides, you can see that I will explain that also. Coming to the water pump, it is a centrifugal simple water pump driven by the belt. It is having a thermostat to open it at 72 degree, and it gets fully open at around 80 degrees centigrade. And after that, flow of water becomes continuous. There is no restriction for the flow of water to maintain the temperature of the engine. The recommended oil, what we are using is 15W40 API oil. So this is one of the model where Greaves the engine oil we are recommending. But if it is not available, you can use 15W API grade oil, whichever it is available at your end. Engine is with starter motor, so you have to have an electric circuit properly to maintain this electric starter motor operative. Then charging is with flywheel mounting alternator. There is an alternator fitted in the flywheel. And that can then low idle is 1200 RPM, high idle is 4000 RPM. As soon as it reaches 4000 RPM by data set itself, it get cut off. So you won't get higher RPM than that. So based on that, you have to decide your gear speeds or gear ratio, what do you want and what is demanded for the durability or endurance test. This is a tappet settings where we recommend to have almost 150 microns or 0.15 millimeter of setting between both before the start of the engine. Then coolant, you can use a normal ethylene glycol in the ratio of 70 part to 30 part of soft water or whatever the water is available at your end. This is the engine performance. It is earlier also we have shared to this. It's 7 kilowatt engine. It's a very gradual curve. And you can see the torque value at lower RPM torque is almost flat. So that will give you a good drivability when you are using a varimatic type of gear ratios, powertrain or gearbox. BSFC is having a reverse hauser, normal like IC engines, and it is better. So these are basic curve for the engine. If anybody requires for simulation, that can be used for it. Go to the next slide. Now, this is a pictorial view of the engine. So I think few of them are already having engines. Some are now buying the engine. Just to explain you, this engine is a very simple, compact engine. And the length is almost 330 millimeter and width is 358 millimeters and height is 485 millimeters. Then it's a flywheel pulley to gearbox mounting. Is equal to almost 300 millimeters are there, and distance between feet is almost 266 millimeters are there. So these are already mentioned in our rule book, so it will help you for the mounting guideline point of view on your vehicle side. It has to be mounted vertically. Please ensure that engine should be mounted vertically. Yeah, you can go to next slides. Now there are sensors and actuators on the engines, so that has been explained in this figure. Engine is having an HT cable where the spark plug is connected to a HT coil. You can see there. Then there is an injector, CNG injector on the manifold. Then oil mist separator. The main function is there to collect oil, the mist vapors, and drain it to the crankcase so that no oil should be mixing in the combustion and no hydrocarbon increment should happen. And it is a requirement, legislation requirement for the environment point of view. Spark plug is mounted on the cylinder head. Ignition coil is also fitted on the cylinder head on the bracket. The starter motor is fitted on the crankcase with a starter plate. Then flywheel is with alternator. Oil pan is beneath the engine. Coming to the right, there is a rocker cover where you have to just open their two bolts and set the rocker tappets. If suppose engine is not performing or there is a metallic or metal noise. So setting is required, but mostly engine comes with setting, need not to set. It is factory setting. If engine is new, if suppose engine has run and it has been serviced, then it requires a tappet setting. Then there is a cap for oil filling. So you have to meter the oil with 1 liter and you have to fill the oil. Then oil level gauge, there is dipstick. You can see to what level, to the maximum level or to the minimum level, the oil is there in the crankcase. It is simple as a 2-wheelers or 3-wheelers you can see. Then there is an oxygen sensor on the manifold, exhaust manifold. You have to take due care for the sensor because it is very fragile and very delicate. Please ensure that it should not bend, the cable should not bend, it should not be touched, it should not be harmed. Please ensure that it should be protected properly. If you can add a guard, if suppose any part is there above, any heated part or any thermal issues are there related to exhaust system and other things, above it, please ensure the cabling should be parked properly on the engine or on your buggy. Cylinder head, of course, fitted on the engine. Catalytic converter is there in exhaust system, but for the hBAJA, I think it is recommended you prepare your own muffler. And if you are going for go green competition, you can add your own catalytic converter and show some difference in emissions there. Then there is a water pump pulley. You can see it is driven by the belt from the crankshaft. Then crankcase is the body of the engine. Then there is a pulsar coil to take the pickup of a TDC pickup for ignition point. Then there is a water pump belt. You can see in this figure. So same engine, same sensor actuators will be there. Is a carburetor also fitted on it. So the rubber hose which is going to be connected to the carburetor, that is not in our scope. So you have to develop that rubber. Of course, it is available in the market. You can use that rubber. You can see the carburetor to the right, just beside tappet sensor. So that rubber hose and everything in rule book dimensions of the carburetor has been given. Just fit that rubber hose. It is available in the market. You can take the size and clamp it properly. Then there are temperature sensors, coolant temperature sensors are there. Then CNG filter is there. Then ignition coil is there. Then oil pressure switches are there. So these are the sensors and actuators on the engine fitted. And similar type of sensors and actuator will be fitted on the engine if suppose you are buying a new one. Go to next slide, please. Coming to, I think I've already explained to you oxygen sensor, then there's pulsar coil. You can see it's just picking up from the missing tooth, which is there on the flywheel. And FMA is a magneto inside it. Like a two-wheeler, you can see there is a magneto here also, which will give you a AC current, and there is a regulator, which will convert AC current to a DC of almost 23 amps as per the requirement for three-wheeler. So that is suffice the buggy's requirement. And there is a throttle position sensor also, which is fitted on the carburetor, which senses the throttle positioning, and when you accelerate and decelerate, it will understand the speed at what engine is running, and based on that, your buggy will run on the track. These are the few sensors and actuators. This is only for your information. What is the function of it? You need not touch these sensors and actuators or remove it because it is calibrated at our end. So there are TMAP sensors, and it is used to measure the temperature and pressure of intake manifold. There is oxygen sensor. It is used to measure air-fuel mixture. Then there is idle control valve, which is used to control idling air for engine. Usually at low idle, you will find some engines hunts. So to avoid that hunting, this idle control valve has been added. And it helps you to stabilize the low idling engine RPM when engine is running at low idling. There is the ignition coil, which transforms low voltage to high voltage to provide high voltage to spark plug. Then there is an injector. A CNG injector is driven by ECU to inject CNG in the intake manifold. Then there is a CNG filter with sensor. So the sensor is a rail pressure sensor and temperature sensor working around approximately from 0.5 to 4.5 bar. So, and it filters almost up to 10 micron impurities. So whichever the impurities coming from the CNG gas, that is going to be filtered here, and pressure, rail pressure will be monitored. Now this is the carburetor. I have already explained to you. Temperature sensor is fitted on the cylinder head, and it monitors the engine oil coolant temperatures in it. Okay, then this is the ECU. It's a small compact ECU. You have to fit in a cold or the cool region on the buggy, either on the driver's side or on the vertical wall. So it will not harm the ECU. It is very expensive, and you have to take due care for this ECU when you fit on your buggy. Yes, please. Next slide, please. This is engine lubrication system. For your information. Nothing to do, but just for your information how this lubrication system works. As you go from the serial order from 1 to 14, oil is in the oil sump. It is sucked by the suction bulb, which is the suction pressure. You will come across there is a, we can say, oil pump, which is a gear pump. So the oil is sucked. It will go to from suction bulb to lubile pump. Then from lubile pump, it will go to the spin-on filter where it gets filters. Then it will go to the main bearings of the engine. From main bearing, it will go directly to the camshaft of the engine. Then there is a pressure relief valve. If suppose internal pressure increases more than 5 bar, then the relief valve will get open. You can see to the left side at the bottom. Number 6, that relief valve is having a spring-loaded plunger. It relieve, and that oil will be again splashed down to the oil sump. Then there is a piston inside it to control that movements. It is, you can see on the engine where lubrication of the engine, the top will have only through the mist lubrication. Okay, that goes in a vapor form, and it will mist the piston and come down. Then the locker arm, it will be lubricated through mist lubrication. Then there is a breather where oil will be separated, and oil will be drained out through the push rods tube. Then there is a drain plug for the draining of the oil. Then there is an oil filling cap on the top. Then needle bearings are there on the PTO side. Then oil seals and oil vapors are there. So these are the basic circuit, oil lubrication circuit of the engine. Now, this is important part for the buggy installation. This is engine cooling circuits. I will emphasize this to the students that you please focus more on this, because the performance of the engine and your buggy will depend more on this cooling system of the engine. Please ensure that the circuit, water circuit, is very, very proper, and it has been validated. It is cross-checked properly that water is circulating properly. For that, some 2-3 guidelines are there, that the degassing tank, which is there, it has to be above the radiator. Okay, and it has to be slightly above the this pressure cap. You can see the serial number 10, the filling cap. It has to be slightly above, say, at least 20 to 30 mm above that. This, it is mentioned in the rule book also. You can go through the guideline. And your filling cap should also be above the radiator, almost 40 mm above the radiators. And you can see the line, water circulation line. Water, cool water is going from the bottom of the radiator, and hot water is coming back to the radiator. And this circulation is mandatory, and you have to ensure the same thing. The water pump outlet you can see, and what is the outlet is coming from the cylinder head. That red line you can see, that is the cylinder, it is fitted on the cylinder head, and the water pump is fitted on the barrel. So your radiator in should be to the pump, and out will be, sorry, water radiator out should be to the pump, and water in should be to the radiator from the top of the side. So you please ensure this line diagram. Red means hot water, and cold, this is cool water if it is going in green. So same routing has to be maintained on the buggy. Please ensure this and cross-check it, validate it from your mentor or the person from the hBAJA team who is guiding you for this building of the buggy. And of course, we are there to support you. If any support is needed, you please contact Greaves team. We can share you, we can join through WhatsApp video conferencing, and we can share you what more we can able to support you for this installation of radiator on your buggy, or to have this cooling circuit properly functioning. Radiator is equipped with electrical fan, and you please ensure that the fan and the shroud are properly clamped and electrical connections are being given proper. Okay, there are coolant drain plugs. I think these are not recommended to be used by students and not recommended by outsiders also. Some experts are needed for that. So please ensure that drain plugs should not be opened by the students. If in case there is some clogging and everything, take help of some mechanics or some experts there. But please ensure your electrical connection to the radiator should be robust enough, and it should not be foul play while your vehicle is running on the road or during the test. Can you go to the next slide, please? These are the radiator specifications. This will be given to you. Just to share you, it is having a heat dissipation capacity of almost 6,500 kilocalorie per hour. It's a very good requirement. Our engine doesn't require more than 4,000 kilocalories per hour in full load conditions. So it is very well and safe radiators. Get this radiator. I think it is available with SM Autos, and even I think vehicle manufacturer can able to give you, or you can contact your hBAJA team. If any supplier has been tied up by hBAJA team, you can purchase from there also. Yeah, next slide, please. These are the some layout drawings on the buggy on as well as three-wheeler. We have just given a pictorial diagram how it is fitted. Laterally it can be fitted, in front also it can be fitted. And you can see the line how it is been given, especially the filler neck. You can see it is above the radiator, slightly above the engines also, almost 40 to 53 mm. Now recommendation from center line is 57, but if you cannot measure center line, just check the top of the piston and take 40 mm above it. That will be better. So that is the recommendation for the filler neck, and rest I have already explained you. This red line is, I think it is hot line, yes, and blue line is a cool line, where it will go to the barrel, and from barrel it will go to the cylinder head, and then it will become warm up, and then from cylinder head it will go again back to the radiator. So this is the diagram it shows. You can go to the next slide. This is the water pump on the engine. I've already explained to you, and there is a hose connection pipe also there. So you have to clamp the rubber hose with the help of a proper clamp there. And then there is a thermostat above on the cylinder head. Yeah, you can go next slide. Okay, no problem. These are some layout drawing, self-explanatory. So this is oil mist separators. I've already explained you the function of oil mist separators. Only the objective is to separate the oil from the vapors, what is coming on the above the cylinder head. So the oil mist separators actually separates 98% of oil from the cylinder head or from the vapors, and 2% of oil may go to the atmosphere. And of course, we are connecting it to the air filter. So need not worry. It has to be connected. The hoses are available where this outside we can say outlet of the OMS can be connected to the rubber hose to the intake of the air filter. Rest it will filter and the oil will come directly to the oil sump. So this part is fitted along with the engine. So only thing is that outlet that hose you have to connect to the radiator. That much only you have to do. And pipes are available and radiator hoses are also available in the market. If you need any support, you let me know. We can also suggest you which type of hose to be fitted on it. You can move. This is the charging system of the engine. You can see to the right, there is a picture of the flywheel. There, one tooth is missing. So that is a pickup of the TDC. It has been casted and machined properly. So nothing to be adjusted by the students and it is fixed on the engine. So objective of the FMA is to give the current, AC current to the requirement of the vehicle. And you can see it will give a AC current and then it is to be clubbed with a regulator. Regulator is in a scope of supply. We are going to offer you that regulator along with this engine. So only thing is that you have to connect the coupler to the regulator and the regulator output, one of the output will go to the battery charging system, other will be going for the other application of the vehicle, say starter motor application or some other lightning application. So the circuit diagram is very simple and it is available in our workshop manual. If you feel or you're stuck somewhere, you can loop us. We are support to that. We'll support to you for that. So main role of the regulator is to convert AC current to DC current. And you can see the requirement on an average, you will get 23 to 24 amps easily at your operating RPM of 25 RPM. And if you go for full load conditions, say 4000 or 3500, you will easily get around 30 to 35 amps. So that suffices the requirement for the radiator fan or any other lightning application or other CNG kit application. This current is suffice and we have already done charge balance for three-wheeler. And for the buggy, of course, your charge balance will be lesser than three-wheeler. So need not worry for this charging. Current is adequately available. If it is not coming, please look out for the wiring harness, what is been designed for your vehicle. Is exhaust system, I've explained you already. This is a silencer with catalytic converter and it is directly mounted on the manifold. So please ensure that we are supplying, I think, but what recommendation from hBAJA that students will develop their own exhaust system. Please ensure the flanges, what you are fitting is a proper flanges on it. Its PCDs should be properly fixed. It should not be tight fit, no bends. It should be flat machined. Flanges should be there. So to avoid the exhaust leakages and other things. And mounting of exhaust system should be in a proper way. Being it's a highly thermal, high temperature zone, please ensure that should not come nearby to your wiring harness or any CNG line which is going nearby. Please ensure that all fuel lines should be away from exhaust system. Our recommendation, it is worth if you can lay out is from the intake side, because that is the cooler zone of the engine side or the buggy side, and this is the hotter zone. Avoid it and properly mount it, this exhaust system, and ensure that the exhaust gases should go from the bottom of the vehicle, not on the top of the vehicle. That will be most recommended side from our side. Well, last time we have seen that some buggies are having silencers above, like tractors and other things. So that is not recommended. Please ensure that. Now the belt, it is a multi-groove belt we are using here. It is fitted on the engine and it is having some guidelines for that. It is a 3PK belt and you can say coplanar and of the flywheel and water pulley should be within 1.42 mm. You need not bother. It is by default, it is going to come. These are only for your information. Then installation belt tensioning is we are measuring with some frequency gauge. Say it is showing that 212 to 269 frequency gauge. This also you need not worry. It has been set by us to this frequency, so there should not be wobbling of the rubber belts on it. Then end of life for the tension is 150 hertz. So it's a new engine. If any old engines are there where you feel that the belt is wobbling, please replace the belt as per our specification guidelines. No tension mechanism is required as it is auto stretch belt, so need not to worry about it. Now coming to the CNG fuel layout is a very simple layout is there. And I think same is followed by your colleagues who has demonstrated earlier on their buggy. It is a CNG tank. You can see to the left, yellow color, then followed by a fuel CNG tank assembly. There is a CNG filling valve on it. Also, there is a gauge where it will show how much percentage or how much CNG gas is there in the tank. Then there is a high pressure line. This is a Bundy tubes, and it can withstand to almost 400 bar pressure. So need not worry for this Bundy tubes. It's available, and vehicle manufacturers or the CNG suppliers will definitely give you. It's available. Then there is a regulator, inline CNG regulator. The objective with the regulator, it is a single or two-stage regulator where this 200 and now we are using hCNG. It will come around 250 bar pressure. So 250 bar pressure will be come down to almost 2 bar operating pressure. So this is the objective of this regulator. This has been validated. This regulator is compatible for hCNG and CNG both. So not to worry for that. Please ensure that whatever the ferrules are there and everything fitted on it are properly clamped, and it should not be leak proof. It should not leak. It should be totally checked by some soap water and other thing. It should not leak there. It should be foolproof from the leaks. Okay, and the regulator is with solenoid also. So when it is not there, the solenoid get off. When it is operated, solenoid becomes on. So rubber low pressure hoses are mostly rubber hoses, and this will be provided by vehicle manufacturer to you, and it is connected to the CNG filter, and then from CNG filter it will go to the CNG injector. So this is a simple layout drawing, very easily packageable on the buggy. These are some of the pictures of the three-wheeler, how these ECUs are mounted, how the CNG line is going. You can see ECU mounting, then CNG regulator, how it is fitted, how this piping has been done to the long member of the white tube. You can see how it is going and how it has been parked and clamped. So we expect the similar parking and clamping of HP high pressure pipes, CNG pipes on your buggy. Just to show you how it has to be packed from the CNG cylinder to regulator and other. These are the wiring harness. So yeah, this is the layout. I think we are providing you this layout. You can study this terminal diagrams and accordingly, or you can directly take a wiring harness from our supplier. Need not to study, and just as per the wiring harness, which are the coupler which has to be fitted for the different actuator sensors that you have to clamp it. So you will get this from our hBAJA team. You can just inquire with them who is supplying this. I think Advantech or Atul Auto is going to supply you for this. You can go next. The gasoline fuels system is simple, as if of two-wheeler. You can see there is a tank. This is a 3-liter tank. Then there is a filter. Then there is an electrical feed pump. If your tank is below, if tank is above, no need of using filter. Then there is a rubber pipe directly connected to the carburetor. And based on the throttling of the carburetor, the fuel demand goes to the carburetor, and it is combust in this combustion chamber. Similar like two-wheeler application. This I recommend student that you use this for your optimization of buggy performance. Then finally you can switch over to CNG. Then finally you can switch over to hCNG. So you are having advantage with our engine. Optimize your buggy with gasoline fuel or petrol fuel. Use CNG to see the performance. Then you upgrade it by using hCNG fuel to see what is the performance you are achieving with hCNG. So this is the layout drawing for on the vehicle. Engine to the carburetor, then carburetor to the rubber pipe connected to the feed pump to the filter, then filter to the tank. So this will be in our scope. You will get this. Tank you will not get, but filter and other things we are supplying along with the engine. This is the air filter connections. Air filter connection is simple. Air filter will be in our scope of supply. We are going to supply. Please ensure there should not be a sharp bend. You see the rubber hose, how properly it is fitted rubber hose to the air filter. You please avoid squeezing of the rubber. Don't use lower grade rubbers with the air filter. Use a proper grade rubber so that it should not bulge or it should not squeeze while running engine. Mostly when vacuum is more, the rubber gets squeezed and there is no proper air circulation in the engine. So rubber hose you prepare. We have recommended certain rubber hose. So that rubber hose will be available in the market. You please purchase that and fit it, or you can develop as per your requirement. So this is a simple layout. This is a repetitive slide. I think just skip off all repetitive. These are some photos. Just hold on. No, buggy photos. So this is the engine layout. Okay. These are some photos of the buggy. You can see how it has been mounted. So take some guideline from this presentation and you can explore your mounting and other things. Okay, then you just go back. Some tightening talks are there. These are tightening talks. Please refer this. Please refer this tightening talks when you are fitting or tightening different rubber hoses or the different nuts and bolt. We have given some tightening torque. Use a torque wrench to have a proper tightening torque. There are certain sealants required. These are all available in the market or at the dealer end. You can use this sealant for your whenever it is required. So everything will be provided to you. Go down. Service schedule. Service schedule. These are service schedule. These also we have given in a workshop manual. But for till 1,000 kilometers, nothing to be changed. Suppose 1,000 kilometers and above, then servicings are required. So I don't feel so you'll run 1,000 kilometers when servicing is needed. If in case it is needed, you just check it, which has been mentioned in till 1,000 kilometers. Yeah. Next slide. I think these are last slides. Yeah, a few of the photographs. Now, question and answer session. You can please ask questions if you had anything. So session is open. You can place your question. I will try to respond to your question. If suppose any more clarity is there, that can be answered through email or through hBAJA team.
Teams, if you have any questions, please ask, or you can drop your question in chat box also. Sandeep, you can read that question and ask to sir.
Okay.
Okay.
So there is a question from Team Rocket.
Yeah, Rocketeer Racing Team. The engine crankshaft
shaft
appears to be rotating eccentrically. So it is not spinning uniformly around its axis. What can we do with it, sir? Then there is fundamental, some problem is there in the engine. Can you share some videos to us? That will be there. My email address is available. Just share the videos to us. I can able to sense what is the gravity of the failure, whether the spline has broken or something happened to that engine. If something happened, you send that engine to us, we'll repair and send it to you. Okay, that is one option I am sharing you. But I want to know whether the shaft has broken from the spline side or something different.
Okay, sir.
Then second question is, what is that? Is
fuel
pump required if we mount the fuel tank above the engine? No, not required. Fuel feed pump, gasoline you're talking, not required. What is working pressure of OMS? No, it doesn't work on pressure actually. It is a diaphragm type of, we can say, enclosure where our crankcase pressure goes maximum to 1 kPa or less than 1 kPa. So need not worry for that. So only it separates the oil inside it. And there are separators, different type of flow patterns are there, wavy patterns are there, or some we can say maze type of patterns are there inside. So it filters through while gas is passing through it. So being oil is somewhat heavier, it gets settled down, and from the settling of membranes, it goes down to the crankcase. Does change in 5 to 18% of hydrogen affect rubber components for old engine? No, it doesn't have any impact. This we have checked it. CNG and hCNG are not available. So how much power loss there in petrol to CNG? Petrol will have higher power. CNG, there is a drop of almost 12%. We observed it. Any more questions, please?
Teams, any questions is there? You can post or you can unmute yourself and ask the questions. So there is a question from Aditya. Sir, could you please share the slides with us so we can refer to them later?
Yeah, I think it is with you. You can. I think Rameshwar, you can share, not a problem. The slides you can share with the team.
Yes, sir. Yes. Teams, more questions you have?
For fit, sir, could you share? Okay, thank you. For fitting of wiring harness, it is like I'm not clear with the question. Shan, you can demute it and explain it. Unmute it, please.
Oh, yeah. Can you hear me? Hello.
Yeah, I can hear you, Shan.
Yeah. So I was asking, like, is it like a plug and play type, like wherein like when we purchase the kit from Baha, do we have to make any modifications to the whole wire harness, or is it like just for like assembly?
No,
Is it
no,
ready
you
to
have
be
to do
assembled?
certain. You have to do some
Okay.
wiring harness. Reason is that, Shan,
Okay.
wiring harness is having cables for your dashboard also. Okay, dashboard of the vehicle.
Right.
So dashboard you are not using, or maybe some speed, maybe you are moving minimum. So I think our team will visit, or Atul Auto team will visit, or Advantech team will visit. They will educate you what to defunction it. Okay, or which is not required, you can disconnect it. That one.
All right, sir. Thank you.
Yeah.
So there is a question from Achtanand. Sir, can we use manifold?
Can we use?
Manifold.
I'm not clear. Can you write it down just on manifold? What is it? Manifold.
Yes, a manifold.
Where you want to use that manifold? Means intake side, or where you want to use it? You want to refer certain slide, so you want to share, you can go to the slide and you can explain there. Go to the engine directly. Yes. Where you want to use that? On the carburetor?
Yes, sir.
Hello?
Team, you can
Sir,
unmute
hello.
yourself.
Yeah, please ask. Feel free, yeah.
Sir, it is
Not a
air
problem.
intake side. He's asking
You
air
can use,
intake.
but manifold, you can use manifold, but again, manifold, if it is available, readily available, it is okay. But how you will going to clamp? You need a small rubber hose which need to clamp to manifold as well as to the carburetor. That small rubber hose you can use, then you can use the manifold if it is available, or the steel bend pipe. What do you want to use? You can use it. Not a problem.
So there's another question from Rudra Raju. If
Yeah.
increase in hydrogen to 18%, need to change the head or components of engine? If yes, how do we need to send our old engine to your facility?
Not required actually. We have already, I told you, when I started the presentation, we have already validated this engine with CNG, with hCNG. There is no single component which requires change. 18% hydrogen on CNG is safe. Not required any change.
There is question from Karthik. Sir, can we get the wiring harness diagram?
Yeah, it is provided, na? In rule book, it is provided. If it is not there, Rameshwar, I think Rameshwar will provide you whatever your queries is there. hCNG team is there, technical team, they will provide you everything we have provided to hCNG team. So all technical details is available. If it is not available, please write to us. We will send you. Not an issue. And wiring harness, harness is there in the workshop manual also of Greaves. You can refer that also.
Sir, if they want, they can refer TD also.
Terminal diagram also can give you the details.
Another question, sir. Is there any regulation on the position of the radiator?
No regulation. There is no regulation as such. You can fit, you can mount in sidewise, front-wise, backside. No regulation. Ensure water circulation should happen properly.
Sandeep, there is more questions in chat box.
No, as of now, just we can wait for a few minutes. If there is no, we can continue this further session.
Okay, okay.
I think you can just remove the presentation now. And yeah, thanks team for your giving time for this presentation. And I expect you will do better and best in the coming event.
Sir,
yeah, Sandeep.
there's
Yep,
a question
Sandeep.
from Harish. Does
Yeah,
the change in hydrogen to 18%, we need to tune ECU?
Yes. That we are doing. We are doing, and the old engine who has purchased it, we can provide you a new data set for that. Just you have to flash the data set. If that is not you cannot able to flash it, we will support you where that ECU can be sent to us, or our engineer will come there and flash it, because it needs a computer there, and with the help of a tool we have to flash it. So that we have to check it. But rest assured, whatever the data set is available with you, you can prepare the buggy, you can run it on hydrogen as well as, CNG and gasoline. As soon as we are going to switch over to hCNG, if the hCNG is available, then at that time also we can flash that data set. So need not worry, we are there to support you for that.
Okay, sir. Harish, hope your question has been answered. Still any questions, teams?
So my best luck to the team now. Prepare well. We are there to support you, and definitely in events we will be there as a team to work along with you.
Yes, sir. Thank you. Thank you for the insightful session, Kalim sir and Suresh sir.
There is one more question in chat box. We were told that there might be some changes with the CNG cylinder, as told to us during the introduction brief meeting. So can we expect any changes to the CNG cylinder, or can we just keep the same one of the last year for charge?
No. I think to my knowledge, they are going to develop Type 4 cylinder, Mr. Ajit Babu, Dr. Ajit Babu, and they are going to supply that Type 4 cylinder head. But Type 1 cylinder head also is adequate for 18% hCNG. So those who have purchased that Type 1, the earlier cylinder, I think it will work for hCNG. It may not have any effect. Suresh, you want to tell something, please? Suresh is my colleague.
Sir, for hCNG, if Ajit sir, they are giving the new cylinder head, no, that will be lighter than the existing one. That will be best for use. Hello.
Yeah.
Yes, sir. You're audible, sir.
Yeah. Thanks for information.
Yes.
Okay, then, team.
Team,
yes, sir.
There is no questions. We are closing the session.
Yes.
So there is another question. As it's an CNG preferred engine, is there any issues running on more gasoline?
No. Nothing. There is no issues. But you ensure that after treatment, anyway, there is no emissions as such. So usually prefer when vehicle runs on the field, now they will run on CNG. But this is all experimental. So there is no emission requirement and other things. If you run on gasoline or CNG, it doesn't matter much. What happens when you run on gasoline? Now something lambda becomes rich, and your after treatment may get damaged. Means conversion efficiency will come down for hydrocarbon and CO. That's why most of that in the field vehicle runs in CNG. Gasoline they runs very less. But now since it is an experimental and students event, you can run on gasoline, you can run on CNG, or you can run on hCNG. Not an issue. It doesn't have any adverse effect. on performance.
Thank you, sir. Teams, any questions?
Sandeep, I guess we covered a lot of questions. So thank you, Kalimuddin sir
Sir,
and
there's the
Suresh
last
sir for the
question.
joining. Okay,
Yeah,
ask.
please, Sandeep.
Sir, how far should we keep the cylinder from the exhaust? Can we use heat shield cover to reduce the clearance?
Uh, uh, I think this presentation, in my presentation, if you go to the slides, you can see the packaging. I think, Rameshwar, if you can again put that slide, the photographs where I've shared some buggy photographs.
Yes, sir. 1 minute, sir. I will share
Yeah,
in
so
the
that the students
presentation.
can able to understand how it is packaged and what are the clearances they have kept it. Air gaps should be
sir,
sufficient.
sir,
Yeah,
even
this
I
photo.
think in rule manual it is mentioned, sir.
Yeah, just hold on. You can see the middle photo. Just hold on. First. No, sir. Yeah, you can see the middle photo. At the bottom, there is a tank. Okay, on the side also, you can see below the tank. So there is adequate space. You can able to have what I suggest you should have a proper air gap, and it should not be nearby to any fuel line or exhaust line where high temperatures are there. So packaging can be at the bottom, packaging can be at the middle, packaging can be at the above based on your design of the buggy. Most recommended if it is bottom, your CG will be at bottom side. So your balancing of the buggy will be better. So during your endurance trial, it will support you to run more. That is my thought process. But of course, there are certain design of the buggy where tanks can be fitted above also. Just go to the next slide whether the tanks they are fitted above also. Let me check.
Yes, sir. Here only.
Yeah. Here you can see at the middle they have filled, not at the top, but at the middle. So that is also one of the design where it can be fitted. But of course, you please ensure that there should not be any hot line nearby and there is a proper ventilation of that CNG cylinder, especially towards that filling side. And it should be serviceable also. Huh? It should not be that they are fitted and you cannot do service. You please ensure that also.
Thank you, sir.
Any more questions?
No, sir. I think we covered a lot of questions here.
Yeah.
Yeah.
Who's next session now? Next session is
Sir,
with whom?
Rajiv Gaiki sir have a next session at 12. So teams, you have a short break for 30 minutes and you can rejoin at 12. We have next session of Rajiv Gaiki, regarding the hCNG fuel system.
Okay, then. Thank you everybody.
Okay, thank you, sir. Thank you
Thank you
for
so much, sir.
joining. Thank you, Suresh
Thank you.
sir. Thank you, Kalimuddin sir.
Thank you, everyone.
Team, you can take short break or you can be here for 15-20 minutes. We have a next session of Mr. Raju Gaiki. We will talk about the CNG fuel system and the components. That is the important topic as well. So we have we are using CNG of 18% hydrogen. So that will be very insightful and helpful session for you. So be here and we will start the session at 12. And one suggestion is there. So if you have any doubts, you can ask in chat box, and you can unmute yourself after the session and you can ask directly to the speakers. Don't hesitate to ask the questions. Sandeep, we will start at 12.
Yeah, sure.
Yes, participant, please be here.
ये कैसे होगा अभी कनेक्ट?
Hi Rajesh sir, good morning.
Good morning. Good morning.
Sir, we are on like short break, so we will start at 12. That's fine, sir.
Yeah, definitely. We
Yeah,
will on
okay,
connect at
okay,
that
okay.
time. Okay. Till
Okay,
that
okay,
till
sir.
time I'll just to make my some settings so it will be
Okay,
useful for all. Okay.
okay, okay, okay,
Thank
sir.
you. Thank you.
Yes.
आज मी तुम्हाला घेऊन आलेले आहे
Raju sir, can we start?
Okay.
Yeah. Okay. Sandeep, please start. Sandeep.
Yeah. Look.
Is it required? Should I start my
Yes,
camera
just a
or
minute,
it is okay?
Sir, can we start with your introduction first?
Okay.
Yeah,
It's
Sandeep,
my
please go
pleasure
ahead.
to, yeah, sure. It's a pleasure to welcome Mr. Rajiv Gaiki, a seasoned expert in alternative fuels technologies and currently working with Advantek. With his rich industry experience and activity involvement in forms like hBAJA SA India, Mr. Gaiki has been industrial in promoting clean and sustainable mobility. We are honored to have him here. On to you, sir.
Yeah. Good morning and good afternoon. At a stroke of noon, we are going to be start with Advantech Systems, which is play a vital role. Am I audible clearly?
Yes, sir, you're audible clearly.
Clearly, no?
Yes, sir.
Okay. So I'm just going to be start with the small introduction of Advantech fuel systems, and we go further. So Advantech fuel system, it is playing a vital role in automotive, which is very well known as a gasoline fuel system with in India. Specifically, I'm talking about the India. We are using the finest technology to achieve a best throttle performance as well as a best emissions, which is controlled to the environment, and which is very good to environment also. So our motto is blue sky, green earth. So this is our main motto. So we can go further with our technical systems and further. So first of all, you must. I just joined here now. Is Grew's presentation is completed?
Yes, sir. Grew's presentation is completed.
Okay. So based on that presentation, I am starting on. This is a exactly system which is we are using in engine management system, which is known as the engine management system. So it having it is the exactly placement of all sensors and components which we are using. So can you just move on next? Next, I'm come to the directly engine management system. Shall I share my screen so I can easily move forward? Is the appeared?
Yes, sir. It's visible. Yes.
Okay, so I'm just starting my screen. So first of all, what we can we will start with the what is the exactly this is the exactly layout of a engine engine peripheral part. So it consists electronic fuel system, carburation system with a TPS. We are currently we are not going with the carburation system with hCNG 18% CNG. So it will be it will be a directly a throttle body injection. Injection system for an injector, low pressure hose, high pressure hose, filters, regulator assemblies, gas cylinder, and most important thing is the oxygen sensor, because our lambda system means Styco system is working on a oxygen sensor. So it will be a take all temperature, pressure measurement from the environment, from the other map sensors and temperature sensors, and it will play a vital role to give a accumulate exactly the requirement of a engine system or to ECM. So in the system, sensors are TPS sensor, TMAP sensor, fuel rail sensor, ECTS means engine coolant temperature sensor, oxygen sensor. Most important sensor is a CKP, crank position sensor. It's a primary sensor which without this sensor we cannot start the engine, means we cannot crank the engine. So this is a primary sensor. Other are the tertiary, means secondary system. Second thing, vehicle speed sensor, which is involved with the your transmission system, and clutch switch is very well utilized for the clutching and declutching while whether the engine is stopped or whether engine is in a running form. Second thing, the actuator, ignition coil, gas solenoid, CNG injector. It's we can say is a gas injector, gasoline injector, PWM valve, and starter solenoid. Don't be confused in the sensors and actuators. So these are the vital playing teammates in our ECM system, which is known as engine management control. First of all, we start with the ECM, which is a brain, and others are the peripherals. We are using particularly ECU, which is a model name is a A47, which is very specially work for the single cylinder engine, and it is around 5 years. It is working very well in the automotive area in India for the three-wheeler system. So it is actuator. It is a collaboration with the collaboration of actuators and sensors, which is play a role to run the engine to optimum performance, as well as giving a predominance emissions also, who control the completely pollutions, who cut off the maximum limit of hazardous gases, which is NOx, nitrous oxide, as well as carbon monoxide, as well as which is very well known as a hello. Connected? Connected है? मुझे आवाज नहीं आ रही था.
Yes, sir. You are not
अब आ रहा
audible.
है सर.
I
Now
thought
it's
Yes,
audible.
I'm just get disconnected. Rameshwar, just
Yes,
after
sir.
2 lines, 3 lines, you just make assure.
Okay, sir. Okay.
Okay. So this is a general engine closed loop systems, which is we can say the technical specification. We consists of a coil of a sparks, coil of control of injections, airflow. Airflow is controlled by the electronic throttle control, which is a carburation or electronic throttle body, as well as some indication lamps for the most probably the overheat lamps and check lamps, which is engine malfunctions lamps, which is very known as in a BS4 to BS6 era. So, and communication will be nowadays the automotive system is communicating with the CAN communication system, which is very used for the diagnosis. Earlier one is a K-line diagnosis. Now the T-map sensor. What is the exactly use of a T-map sensor? It is a sensor which is a mounting on a manifold. Don't get confused. It is a mounted on a manifold, which is directly sense the air of pressure of a air, atmospheric air, as well as temperature inside the manifold, not from the outside of a atmospheric. So don't get confused in a MAF sensor and MAP sensor. TMAP sensor means MAP, manifold absolute pressure sensor. It is used in a gasoline system. Don't get a confusion. On a gasoline system, TMAP sensor, MAP sensor is used, and for a diesel sensor, for a diesel system, MAF sensor is used. Okay, so can we go further? It is working on a 5-volt systems, and it gives exactly gives exactly pressure and temperature to the ECM. According to that pressure and temperature, ECM do the corrections with respect of a oxygen sensor, and give exactly lambda system means stoichiometric ratio to the engine. Next, oxygen sensor. This is our main sensor we can utilize for the feedback system, and it is there are a number of sensors, a lambda sensor available in the market, but we are using heated type of oxygen sensor, or forward or heated type. It is working between the voltage 0 to 1 voltage, and the absolute value is a 0.45. And it is whenever it is in actual condition, it is working with 0.2 to 0.9 voltage. It is dangling between that, and it is correcting the exactly ratio of air and fuel for the performance and emission. So all things is working on this sensor because it's a feedback sensor. Now moving to next. Okay, this sensor is mounted on exhaust manifold, just after the exhaust manifold. Next, engine coolant temperature sensor, which is work on a 5-volt sensor, and it is a measure the exactly temperature of a coolant, which is we use as a water plus glycol mixed, which is exactly the ratio of 80 to 20 or 50% of a coolant and means coolant and water. And it is mounted on a cylinder head, where the best possible temperature area, heated area we are getting. So maximum temperature area he's sensing and gives a exactly feedback to the system. If engine get more than 100 degrees centigrade surface and as well as coolant, so it will be hazardous. So according to temperature, the fuel flow ratio as well as safety system is triggering. So this is the use of a engine coolant temperature. Next, ignition coil. Ignition coil is giving a ignition coil is giving a exactly spark to the spark plug, which is generating a spark to the for the ignition inside the combustion chamber. So it is depend upon the how much voltage and how it will be a transfer from 12 volt to maximum voltage around of it is it's have this coil having this particularly this caissons make coil is having a 33 kilowatt, and it is controlled through CKP sensor, crank projection sensor. It is work on the timing of an engine, where which is a layman language. If a timing is mismatched, the spark will be a mismatch to the after the strokes of an engine. So Rameshwar, if anyone having any question on between this, anyone can ask also.
Okay, sir. Okay, sir.
Okay.
We can do one thing. Like after the sessions, we can ask all the questions. No?
Yeah. Okay. No issue. But everyone should be work with all sense, 5 sense.
Yes.
Okay.
Teams that
so it's a
you have to
sensor
ensure
sense
that.
actuator. So everybody with not a dumb body with the work with the means actuate with the all sense.
Yes, sir.
Next. This is the CNG system layout. Please take a picture from your eyes, from your mobile phones and anything, because this is the exactly layout which we have to maintain in your buggy system, buggy vehicle system. So CNG system. Okay, so I'm starting with the cylinder which is steel cylinder who can carry 250 bar of a gas pressure, who can store. Then it is the cylinder system it is mounted on a chassis of a vehicle, and on this cylinder there is a cylinder wall which is relieves the pressure for the system, as well as if it is get more combust for the inside the pressure is get more than 250, it is having a pressure relief valve which is directly populate according to temperature, means it is a work on that. Second thing, a high pressure tube. High pressure tube is transferring gas 200 bar to the regulator. So it is a completely sealed one, leak proof, leak proof. There are the two kind of a high pressure tube. One is a steeled, rigid one. Another one is a flexible one. Now this year we are using the rigid high pressure tube. Next, move to the regulator. Regulator the use of a regulator is exactly to to regulate a pressure of a gas, means we can use as a natural gas from 200 bar to 2 bar, because we this system is working on a 2 bar pressure system, which is a work on an injector. So it is a regulate the high pressure to the low pressure. Now next thing is the LP hose, low pressure hose. It is a rubber tube which can be utilized for the 5 bar pressure system. Next is a filter. Filter is used for the to remove the dirt and foreign particle from the gas, means natural gas which is used in a which is present in a cylinder. And another is a LP hose to the connected to the injector, and injector who mounted on a manifold and inject the gas according to timing of a engine. Next, now CNG system of a layout. The main component, which is I have already explained, CNG cylinder with a tank valve, filling nozzle, CNG pressure gauge, micro switch. Micro switch is a safety system. If micro switch is on, engine not getting cranked. And micro switch is on when you are filling your CNG cylinder on a gas pump or gasket pump. Second thing, a high pressure regulator assembly. The CNG solenoid benzo with the T assembly. It's a regular part. Once you see the physical part, you will be betterly understand. CNG filter. CNG filter is a natural gas filter which is removing the dirt, oil, and any other foreign particles like metallic or any metallic, non-metallic, ferrous or non-ferrous parts from remove for the gas, and do not allow to the injector. Injector is a injecting a gas, exactly amount of a gas into the manifold, engine manifold. High pressure hose and low pressure hose. They are the mostly known as a pipelines. And this is a bomb bill of material which you are going to be utilized in your buggy system. Take one snap of this, which is utilized for your next for your reference. Only the one thing is change, which is a third number. CNG high pressure steel tube. The ID and OD will be remaining same. Only the make and it will be a rigid one. Earlier was a flexible one. This is a rigid one. The nuts and ferrule and other fitments will be a change, and quantity will remain same. This is a cylinder which looks like a same. Maybe this is a 20 to 30 liter cylinder. It is pictured in a. It is showing in a picture. Your one will you are going to use around 1 kg of a cylinder. It's a tiny one. This is a cylinder tank valve, which is we talked about, which is consisting micro switch. This is a micro switch. This one. This is a pressure knob, and this is a pressure gauge. And this is a thread which is mounting on a cylinder, a taper thread. This will be an outlet. From this dust plug, and this is a micro switch, you can fill your cylinder with the help of a cascade or filling station or at a filling station. This is the on off valve. While you filling your cylinder, it should be kept open. And these are the cylinder mounting. This is the exactly layout which you can utilize in your system. This is a tank level sensor, which is work on between 200 bar, and voltage value is reflecting from 5 bar to 200 bar. According to that, it is a resistance base. Your this valve is a sorry, it's a gauge based on a resistance base and working on 1 to 5 volt. So most of the time, your valve at a maximus level at here 210, maximus 210. The lowest will be a 2 bar. After that, it will not work. And it is operated through battery, means voltage system, as well as managed through ECM. This is a regulator, which is you are going to be utilized for the regulation of regulate your pressure from 200 bar to 10 bar, or two. We are using a 2 bar system, so it will be a 2 bar. This is the exactly specification how it will be inlet pressure. It is working between the 260 bar to 10 bar. Flow rate is 10 gram per second. Consistent flow. Do not corrosing till 500 hours. Vibration is good, and endurance cycle around lakhs of and it is completely approved with R1110 ISO 15500 AIS. Outlet pressure will be a 2.5 to 5 bar, and it is adjustable through this group, a brass group. This is exactly mounting what we can say the regulator assembly. This is a solenoid which is actuate, and which is cut off valve for cut off or on off valve for the CNG gas. Here the 5 number is a solenoid valve. This is exactly child parts and bob. CNG regulator, which is I already explained you. You want to take a snap? Already I shared this presentation to all. The solenoid valve for a shut off. This is a low pressure filter, which is I just explained it. It is having a plastic body consist of a fuel rail pressure sensor. This is a fuel rail pressure sensor, and it is having one cartridge, filament or cartridge paper type, which used for remove the dirt, to prevent the dirt or any foreign particle to the injection system. This is a CNG filters assembly, which is I explained you. Particularly pre-filter is a 10 microns, which I can say the filament, and prevent the injector from any debris, oil, moisture, or any foreign particles. all foreign particles, it is collected over here inside inside this chamber or bowl. This is a high pressure hose. It is a steel tube. This is a flexible one made of MS. This year we are using SS steel tube, stainless steel tube, which is a rigid one. These are the nuts and ferrules which is used for the leak-proof system. This is a general tube mounting system or layout from cylinder to regulator. Basically, it's a three-wheeler system layout. The main thing is to understand and keep in mind the diameter of pipes. It's 4 is ID and 6 is a OD. This is exactly how to mount a cylinder wall on a cylinder. This is a tool, a special tool for tightening of this wall or removing of this wall. It having 140 Newton meter torque. I will share the exactly or demonstrate exactly how to mounting this or removing this wall from the cylinder. Okay, so these are the important points why we are using natural gas. We are using not a natural gas. This year we are going to use 18% of hydrogen and 88% or around that we are using natural gas. We are maintaining a pressure up to 250 bar with the cascading system. Other things are very similar to CNG systems. This is a best practice or safety practice, which is I will explain you in a physical training, and that's all from my side. Now you can open to your question and I am open to for this answer for the answers.
Teams, if you have any questions, please unmute yourself and ask the questions, or you can drop your questions in the chat box. Then we will ask to the sirs.
Rameshwar, I'm just leaving this. I'm stopping this screen.
Okay, sir.
So
okay.
you can move your this presentation according to your question and answer.
Okay. Yes. Team, please ask the questions, or you can drop your questions in the chat box. Team, you have any questions? Please ask. We are ready to question answers. Sir, there is one question. Last year's. Yes, Sandeep, you can ask.
Yeah, last year CNG hardlines and cylinder can be used for this year.
Can you just repeat your pardon? Can
yes,
you just repeat your question?
Last year CNG hard lines and cylinder can be used for this year.
Yeah, you can utilize, no issue.
There's another question, sir. Sir, this time we are changing cylinders, so we need to replace cylinder valve, regulator, high pressure lines.
I am not confirmed this year you are going to be use a new cylinder or not. But last year cylinder you can use. Which team you are now?
It's Team Amigos, sir.
Amigos, no, I know that. You can utilize it then. But if Rameshwar, this year they are changing with the cylinders and
Sir, yes, sir. We are developing that type 4 cylinder.
No, sir.
Yes.
So my answer is no. You are going to use a type 4 cylinder for specifically made for this hydrogen blend with the CNG system. So you can utilize your cylinder wall on that.
There is another question, sir. Sir, please give the specifications about OMS.
OMS, EMS or OMS?
OMS, sir. OMS.
What is OMS?
Oil mist separator, sir.
Pardon? Can you just explain?
Yes, sir. It's oil mist separator.
Where you utilize that?
Pranita, can you unmute and ask the question clearly?
Yes, sir. Actually, in the previous year, for the preliminary round, they have given to specify the oil mist separator. In the
Do you have any
presentation,
photograph? Can you share me that? I'm still confused what exactly you are asking. Is it a fuel filter, gas, high pressure filter or low pressure filter, or what is the oil separator? Whether it is a engine peripheral system, engine main system, or it's a gas tank system. I have to understand that. Oil separator, oil cooler, there is a number of things. Oil filter also there. In our system, oil separator is there, like a fuel filter. Rameshwar, how much team is joined in this workshop?
Sir, we have around 23 teams and 104 participants.
Okay.
Yes.
So only team Amigos having a questions.
Other teams, you can ask your questions. You can unmute and you can ask your question, please. Especially new teams who are participating, new, they are asked their questions. Sandeep, there is one question you can ask, please.
Yeah, I'm just reading right now. What will be the length of rigid high pressure tube, and how can we bend or change the direction of that rigid pipe?
It is completely depend upon what is exactly where you mounting your engine and where you mounting your cylinder. It is between that. It is not more than the 2 meters. I think 2 meters is very sufficient. And bending for the bending, rigid bending, it is having a specific tools, special tool for this rigid pipe bending.
Next question, team. Yes.
Is another question. Does several number of circular turns or various hard turns in the CNG high pressure line affect its overall flow of the injector, or would it remain the same and won't get affected by the way we bend it?
No. There is a one rule book for bending, and you have already a rule book, so you have to follow. Follow AS 028, a standard for the bending of a tube. For your system means specifically buggy system, you have to tiny two blend just before to the regulator and after to the cylinder wall. Next.
Next question, please, team.
There's a question, best position to mount a cylinder.
Depend upon your vehicle. Where you're going to be mount, under the chassis or the chassis, maybe beside of a cylinder. It is completely depend upon your design team, where the maximist, minimist stress or stress calculated area. Depend on that. But you have to go with your own design. Next. All are the mechanical guys or not?
I guess, sir, there is some mechanical, electrical, or
any
mix.
electrical?
So you have any questions about the electricals or something?
Because
you can
this system
directly
is
ask.
a completely electronic mecha electronic system, and if there is no question on electronics, what is the ECM, how much pins over there, what is the wiring harness, what is the exactly connector of ECM, each and every sensor connector, there is no question on this system.
Sir, I guess that OMS question, the team asking about this part, sir. Sir, my screen is
What
visible.
one? Yeah,
Sir, this OMS is.
Yeah.
Yes, sir. The engine, the OMS comes with the engine itself, sir, as it mentioned here.
Hello, sir.
Can you just explain more? What is a OMS? Or type
Sir,
it.
it's something like, according to our
Oil
knowledge.
separator. Okay. Oil separator. This OMS. This is known as a breather,
Yes.
engine breather, and this system it is required, but it is an engine system. It is not a. It's a grease engine supplied.
Yeah. Okay, sir. Thank you.
Okay, and you can ask this question to the grease presentation when.
Yes, sir. Thank you, sir.
Okay. Okay.
This another question, sir. Do the
Yeah.
regulator or any CNG components are affected if we additionally switch the fuel flow suddenly from CNG to gasoline while starting the vehicle?
No, I'm not getting what exactly you are going to utilize for the shutting off.
Like they are asking, does the regulator or the CNG components will be affecting if they suddenly
No. There
change
is
from
no
CNG
affecting
to
of any
gasoline?
cylinder regulator and a system if you are using or not using. But you have to incorporate with safety system of a same system, means which is on regulator. It should be a equilibrium with regulator system. Is the wiring harness or any separate safety system is involved in this? Hello?
Hello.
Sir. Sir, there are questions. Reduction length of high pressure line gives any advantage, sir?
No.
There's another question from sir. What about the fuel cylinder? Should we change it to type 1 or to type 4?
So that we will
What
tell you, like they are asking about the cylinder, sir, like type 1 or type 4, like
See,
where do you
type
want to
1
buy?
you can utilize, but it is very well to go further type 4 because it's a lightweight, more safety systems. And another, the Ajit Babu is a person who can give a accurate answer for this.
Yes, sir, sure. Thank you, sir. Teams, don't worry about the type 4 cylinder or type 1 cylinder. That will be covered as there is a session with the sir at the day 2. So don't
18%
worry
of
about the cylinder topic.
hydrogen.
For that, Ajit Babu sir will be giving the answer, and we have that on the second day. Storage system and cylinder specification for hCNG and H2. Okay. Hope your question has been answered. You.
So there is no electrical electronics related questions.
Teams, if you have any electrical or electronics related questions, please ask.
Our system is completely working on electronic system.
Sir, we will wait for. Okay, there is another questions.
There is a question. Any change required in ECU or need to do flash it for the new changes?
You have to change with the flashing only. You can utilize the same ECM, but you need to flash. That taken care by me or Advantech.
There is another question. Are there any possible ways to perform the ECU scan gamma diagnostics by ourselves in our in-house facilities if we have it, or do we need to take it to the service center?
We can use a general generic tool for the diagnosis, but till that level, you have to make sure your vehicle should be go up to that level to diagnosis. You got my point or not?
Vedansh, you got your
Yes,
answer, right?
yes, yes, yes. Yes, I got it. Thank you, sir.
Any other questions? Guys, please ask the questions. Like it's helpful for your preliminary round. So
See,
if
in a preliminary round, if there is no questions and it is not according to presentation and any other things, definitely your mark will be cut from my side only. I'm not threatening you. I'm warning you directly.
yes, sir. We will wait for another 2 minutes, and if there is no question, then we'll wrap this topic, sir. Yes.
There's a question.
there
Sir, there is any
changes?
change in the ECU?
Physically, there is no change in ECM. But from the electronically means programmically, it's a changed. We already optimized engine calibration in a GRIUS. So that whatever the optimized software, we have to flash it in a ECM. if those are using a old ECM, and a new team getting a new ECM with the flashed one, new software. Rameshwar, around 20 team you are talking about they are joined.
Yes, 23 teams, yes.
The amigos, I can understand these are the maximist person which is joined over here. Who is another one? Can I get who is the captain and who represent his team?
Okay, sir. Wait. So, like, sir, can I call their name directly here?
They should be introduce themselves.
Yeah,
Any
yeah.
of
Okay.
our team
So
member from the team.
Yeah, okay. So I will call the name of the teams. So Quattro Racing. Anyone from Quattro Racing here? They can unmute yourself and talk. Anyone from Quattro Racing?
Sir, there is a question.
Okay.
From Harish. From the old for the old teams, we need to send our ECU to your facility, or it will be changed in the event site.
Event site.
Okay, sir. Thank you.
Anyone from here? Heracles Racing. Team Demons. Yes.
Guys, anyone from the team who is representing can unmute yourself and just say yes, present or something, so that we can have attendance type of thing.
Yes, sir. Sudarshan Sonani from Team Demons.
Yes, sir. You have any questions regarding the fuel system or anything? If you or your team.
I just want to know the position of cylinder tank. Position of cylinder. So, is there any clearance?
You will receive a guide. You will receive a guide and each and every things how to position of your cylinder. It is according to your systems also, which is you are going to be mounted. Okay. It should be a serviceable and reachable. According to that, you have to mount your cylinder ball.
Okay, sir. And about their casing, sir, how many thickness of sheet is required, or
that is a design the team will be understand.
Actually, Sudarshan, that we mentioned in the rule book. So what?
Yeah, please follow the rule book.
Okay. Thank you, sir.
Anyone from Team Vijayrath here?
Yes.
Vijayrath from
this
Indore.
is Vedansh Patidar. Yes, sir. From Indore Institute of Science and Technology.
Okay.
So
what you are going to be do this year? Something different.
We are working on multiple innovations right now, and
okay.
But we are going with the same engine. We have confirmed it recently, but we are particularly working on the whole new system. Completed the design and other components as well.
Okay. Best luck. See you in the arena.
Yes. Thank you, sir.
Next.
IPS printers. Anyone from IPS printers here?
Hey, Chandigarh team is there.
Which, sir? Team Rocketeer.
I don't know exactly name.
So team IPS printers is here. Yeah. Yes.
Hello. Yes, sir.
Yes, you're audible. Yeah. You have any questions regarding fuel system?
No, sir.
Team Falcons.
Sir, there's another question.
Okay.
Sir, as it is 18% hCNG, the HP lines, I guess high pressure lines are of SS, so it can sustain the embrittlement, or we need to have any other material or composite material lines.
Why we are?
Any support
That's
from
why
your
we
side?
are changed. That's why we are changed with the stainless steel lines, high pressure lines. Old one also work, but from just due to the safety point of hydrogen, we are changed with the SS tube. You got my answer, or should I explain more?
Rudraju, is your question answered, or you need more explanation on that? So he is asking, can you explain more?
See, earlier we are using a flexible steel tube, which is made of MS, mild steel, and it will work also with the hydrogen system with the blend of 18%. But due to the hydrogen is involved in your initial level of initial level, as well as with this buggy and event and other things, we cannot take a risk on a safety system. That's why we changed to MS system to SS system, which is a flexible to rigid system. And once you utilizing your rigid system, there is a no a least percent of a leakage from the joints. That's why we are using SS system for this year, 18% blend of a gas system. Most of the things it is a roof vibration free. Okay. Rubber
Sir, he is
sheet.
also asking, do we need to add any rubber shielding on the lines or no need, sir, for extra safety?
You can utilize that. From your side, you can add anything. Rubber shoes, rubber blocks, or clampings, rubber shielded clamping also.
Rudraju, I guess your question has been answered.
Okay. Anyone from Team Kshatriya here?
Any from Chennai team? Last year, two, 3 teams are from Chennai. Any Kerala team?
So, in the rocket you are using from Chennai, Shishanam Engineering College.
So Arulin Racing from Chennai, St. Joseph College.
So there is no question from your side.
Sir, I have a doubt. Can we place?
When you are going to ask?
Sir, can we place vertically a cylinder, sir?
Vertical, it is not recommended by any rule book, not any standard, not even did by any automobile.
Okay.
What my point, sir?
Sir, I guess. Yes, sir.
I think I guess everybody is satisfied with my presentation as well as question and answer.
Yes, sir. Yes, sir. If anybody have a question, they can send me. I will directly send to the sir, and we will give the answer to you. Uh, so thank you, sir. Thank you
Sir,
for the presentation
just
and
a
your
small
time, sir.
doubt.
You can utilize
Yes, sir.
much and much more cylinders, no issue. But just safety system is yours. Number of a cylinder utilized for the number of means kilometer you can do covered within one time filling.
So for this question, if you want more clarity, you can just ask that on the BAHA forum. So you'll get more clarity. You can use or not, or
Yeah,
you can
yeah.
increase the capacity of
Only
things.
BAHA has to be allow you.
Okay, so then we covered more questions
Yes, sir.
yes.
Thank you, sir, for your
Thank you.
support.
Thank you.
Thank
Thank
you
you
very
for
much,
the
sir.
presentation, sir.
Thank you. Thank you, team.
Thank you.
Thank you very much.
Thank you.
Good
Team,
luck.
after this, we have 1 hour break for the lunch. You can have your lunch and rejoin at 2 p.m. So we have a session of the design validation plan and design failure mode effect analysis by Dr. Ora. So that is also helpful for your preliminary round, where you get the idea about the DFMEA, DVP, about the hCNG, like hCNG component and hCNG vehicle. And I hope we covered the engine part, hCNG fuel system part, and the hCNG technology. I hope you get the clarity about these things. So so be here, or you can have your lunch and rejoin at 2 p.m. Okay. Thank you.
Try to not leave the meeting. You can just keep aside your device and you can have your lunch. Hello?
Yes, Sandeep, you're there. No?
Yeah. I am here.
Team, you can call your colleagues or your teammates don't join it, so they can join and we will start our session. So please call your friends. Team, we are starting in 3 minutes. So we are waiting for the speaker. So he's joining in 3 minutes. So please wait. Hello, Ora sir. Good afternoon.
Good afternoon, sir.
Yeah, good afternoon. Just give me a couple of minutes.
Yes.
Okay. Yes, sir.
Rameshwar, I'm ready. So, is it
Okay,
okay if I
okay.
share the slides?
Yes, sir. Yes, sir. You can share this slide. Yes.
Yeah.
No issue.
No, I will share the slide and I'll change the slide. Is that fine, no?
Yes, 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 sir. Yes, sir.
Yes, sir.
Okay, just give me a minute to share screen. And then are you able to see the presentation?
Yes, sir. Yes.
Yes, sir.
Sandeep, you can start.
Yeah.
Yeah. Okay. Fine.
It's an honor to have Dr. K.C. Vora, advisor of BAJA SAEINDIA and highly respected expert in automobile research and former senior deputy director at ARAI. We dedicate an experience in mobility innovations, engineering education, and policy making. Dr. Vora has a guiding force in shaping India's automotive future. We are privileged to have you, sir. Over to you, sir.
Yes. Thank you, Sandeep. Good afternoon, friends. Today I'm going to speak on DFMEA and DVP. DFMEA stands for Design Failure Mode Effect Analysis, and DVP stands for Design Validation Plan. Sometimes we also call it as DVPNR, that means Design Validation Plan and Report. So you are supposed to do DFMEA and DVP for your entire hBAJA vehicle, or you can just do it for your engine, or you can do it for the hCNG kit, that is the cylinder, the valves, and all those things. However, during the event, we will be telling you what are the various components on which you have to concentrate. Today, please concentrate not only on engine and hCNG kit, but concentrate on the entire vehicle. You have to look at the vehicle as a whole and then do design FMEA. So with this, I would start my presentation. So very many years ago, when Ford, General Motors, and Chrysler, these are the three big companies in USA, and they were doing extremely well. This is during the period of 1970s, when the emission norms came in and safety norms came in USA. So they decided that there are a lot of things which we can do together. For example, nuts and bolts and hardware. You have different nuts, I have different nuts. So our customers, when they have any problem related to repair, then they have to find out different nuts and bolts for different cars. So why can't we standardize them? And that's how the big three, we call them as big three, Ford, General Motors and Chrysler, decided to work together. Even though they are competitor, they said for the sake of customer, we will work out some common area where we can work together. So that's how they then went ahead and commonized all the hardwares. The next step was in design. They also saw that there are different designs, methodology used in automotive application. So what can they do to streamline this design and also teach to the young engineers? So they came out with a new process called New Product Development, NPD. So this new product development originally was designed by Ford, and later on it was refined with the help of General Motors and Chrysler. Under this new product development, whenever you develop a new product from scratch, that time this method is used. If you don't develop a vehicle from scratch and you just take an existing vehicle and modify it, or just change some component. For example, you already have a vehicle which is meeting BS6 norm, and tomorrow you decide that I want the same vehicle to get converted into BS7 norms, then it will not use NPD method for the entire vehicle. It will just be an addition of an after treatment device. But when you look at only after treatment device and you want to do design FMEA or DVP of that after treatment device, then it is a new product development. So for the passenger vehicle OEM like Mahindra, Maruti, Tata, changing just an after treatment device is not a new product development. But for a catalytic converter manufacturing company, altogether changing the after treatment device, then it is a new product development for them. So in new product development, you have to first start with a concept. What type of vehicle I will have? What will be the wheelbase, wheel tread? What will the maximum width and maximum length of the vehicle? Whether it is single-seated or not, whether it has to be rugged or not. All this has to be written down as the requirement. And then based on that, the product concept has to be done. That means I will make a BAJA vehicle which will have a single seater. Its weight must not be more than that. Whatever first slide you generally make when you give a presentation, that is called product concept. The second step is conceptual design. So based on this, so you can make 2-3 concepts. For example, when you are designing a roll cage, you can make 2-3 concepts of the roll cage. One with the nose narrow, one where the nose is not narrow, and so on. And with different pipes, with different diameters, different material. So that is called various concepts. And then you make drawings of these concepts. Suppose you made 3 concepts, then you make 3 set of drawings, and then you sit down for the review. So that review is known as DR1 or the conceptual design review. Am I audible?
Yes, sir, you're audible. Yes, sir.
So that is called conceptual design review. And when you give your presentation in say we have this event on 19th and 20th July, phase 1, you will have to present your concept. So you can say we made 3 concepts for the vehicle, we made 3 concepts for the roll cage, we make 3 concepts for the suspension, steering, brakes, and so on, right? You can make 1 concept, 2 concept, or 3 concept. And then these are the advantage and disadvantage of various concepts. And based on that, so what are the advantages? What are the costs based on, and what are the production viability? Based on that, 1 concept is finalized, and then you move forward with that concept. So when you move forward with that concept, you have to design a component, an assembly, or the entire vehicle, which will be productionized, that means designed for production, right? And you have to make initially an outline of the design, and then finally the detailed design. What will be the material of this component? What is the maximum size of this component? Whether it will be casted, whether it will be forged, what will be the dimensions, and what is the tolerance given to the dimension, what are the limits and fits to be given. Everything is done in the detailed design. After the detailed design is done, again you sit down for design review, that is called DR2. And then once the DR2 is done, it is during DR2 we do design FMEA. During DR1, DR2, we work on design FMEA. Then you make a prototype, make couple of prototypes, make 2 samples, 5 samples, and find out whether mechanically they are fitting with respect to each other when all the components are assembled together, whether mechanically its function is happening or not. All those things you have to check in the DR3. So in DR3, we need to ask questions whether this whatever prototype has been made is good to go for mass production or not. After the prototype is assembled and mechanically and it is found to be okay, then you have to test it. That means you have to put it on the run. So your vehicle must be in running condition and you must be able to run it for 10 kilometer, 20 kilometer or 100 kilometer in your college campus, if you have enough space, or on the outskirts in a lonely place where there are no accidents. Then you come back, you again, based on the failure during the trial run, you can further modify those various components and make the final prototype. And based on this final prototype testing certification, you can start the initial production. So for example, you decide you will make 100 prototypes. I'm not talking about BAJA, but say you in future you are designing an electric two-wheeler, then you make 100 prototypes of those vehicles and do a series of tests and find out, or give it to some customer, give it to your internal employees, give it to your friends and relatives, give it to some press reporter and ask all of them to give you feedback, good or bad. And based on that, you finalize your design, you finalize your drawing, and then the mass production starts. So when the mass production starts, before that, we have long back in the outline design decided what type of production it will be, casting, forging, and what will be the material, and also who will supply. If it is ready-made available, then we need to finalize the supplier. Or if you want some sub parts to be purchased and then assembled together, then also you require the supplier. So you must find out who is the supplier and parallelly start talking to them. So this is how the new product development is done. So finally, this new product development gets converted into the house of quality. The picture which you see here is called a house of quality. And in this house of quality, the center is a table, which we call it as a QFD table or a quality table. So QFD is quality function deployment. And the job of QFD is capturing the voice of customer, VOC. VOC stands for voice of customer. You capture the voice of customer. For example, if you are making an SUV, sports utility vehicle, and some ladies want to get into the vehicle, the level, the footrest is at a higher level, and it becomes difficult for her if she is wearing a sari. So we may require an intermediate footboard where she can put her step and then get into the vehicle. So that is her requirement. Or there may be some girls who would say, I need 99 cars in the vehicle. I need 99 colors. So TVS Motor decided that we will supply two-wheelers in 99 colors. The customer has to tell us in advance what color they want, and we will give them in that color itself. So that is how the voice of the customers are captured. And this art of capturing the voice of customer and then compiling them together and coming out with the final specification, technical specification, is known as QFD or quality function deployment. So once that is done, then we need to do the technical benchmarking. We need to buy some vehicles, similar vehicles, buy some similar engines, strip them, find out what is the material, manufacturing, tolerances, quality, everything. And then based on that, design your own product, which is much, much better than that. So you also need to do product planning. You need to have design targets. You need to have reliability targets and so on. So based on all these targets, you have to find out what are the impacts of this target and what is the cost, what will be the service concern, how will you produce this part, who will produce, all those things will be discussed in this house of quality. Next slide. Yeah. So design FMEA is not only done for design, it can be also done for the manufacturing or the process. So hence we call this as design FMEA and process FMEA. Design FMEA is done to check whether the design is foolproof or not, and the process FMEA is done to find out whether the manufacturing process is correct or not. डिजाइन कितना भी अच्छा हो लेकिन मैन्युफैक्चरिंग प्रोसेस गलत है तो डिजाइनर की मेहनत पानी में जाती है. इसीलिए द डिजाइनर कंटिन्यूज इवन आफ्टर द डिजाइन ही कंटिन्यूज विद द वेंडर, ही विजिट्स देम रेगुलरली टू सी दैट व्हाटएवर ही हैज डिजाइन is properly understood or not. So there is a story of the Taj Mahal Hotel. All of you must have seen that Taj Mahal Hotel, which is opposite Gateway of India in Mumbai. And this Taj Mahal Hotel was designed by an architect from UK. He came, he designed the entire building, entire hotel, and went back saying that I will come after 1 year when the construction is done. And when he comes back after 1 year when the construction is completed, he gets a shock of his life because the front of the hotel, which was supposed to be facing the sea, was rotated by 180 degrees and the front was in the rear in a small lane. So that was a big shock for him. So what I want to say is that when you design something and you make a drawing out of it with all the detailed drawing, then also you don't stop there. You also ensure that during production any mistake is done or not, during assembly any mistake is done or not, and during usage also whether any mistake is done or not. So the designer has to get associated with the component which they have designed or the assembly or the entire vehicle they have designed till the vehicle is launched in the market. So this is the process. Then comes one more area that is called business. You have to make a business case and find out whatever you are doing is correct or not. For example, I decide that I will use gold in my car and then do design FME and DVP. That is all fine. If you have customers coming from Gulf countries who can afford it, you can make some golden cars, but not all, right? So you will have to make that decision from business point of view, and hence during design FMEA, business cases are also important. So in design FMEA, you ensure how the design is done. In process FMEA, you ensure that the manufacturing processes are perfect. And then in business case, you ensure that whatever we do, finally there is an earning and there is a big business being developed out of that. Okay, fine. So this design FMEA, process FMEA and business FMEA can be done at a particular stage, say the phase 2. Phase 0 is a concept. Phase 1 is finalizing the drawings and design. Phase 2 is the FMEA, that is the process FMEA. So in phase 1 will be design FMEA, phase 2 will be process FMEA, and so on. So finally, at the end, you get a product which is good in design, which has no flaws at the time of manufacturing, and it is suited for the business case study. So you always start with a concept, then you do a verification of a prototype, and then you do validation of more products or more samples, and then you go and finalize it. So let's go ahead. So now I will talk about design FMEA, that is failure mode and effect analysis. It's a paper and pencil analysis method used in engineering to just one. Yeah. So here Yes. So here, FMEA, failure mode and effect analysis, you need to take a paper, you need to make various columns, and then you need to find a team. So you have to form a team and then use this technique to identify, prioritize, and eliminate potential failure from the system, design, or process before they reach the customer. So it provides a discipline for documenting this analysis for future use and continuous improvement. So in FMEA, failure mode and effect analysis, you need certain inputs and it will give you certain outputs. So what are these inputs? For example, lesson learned, whatever you learned in the last 10 years, you, your team or your faculty advisor has learned and they have maintained all the records. Then you will come to know what were the failures in earlier days, what is different now. Earlier days we used to do very well. Now comparatively we are not doing well. So what do we do? All those are discussed in lesson learned and brainstorming. Then comes the process map and process history. So you make a process map of how things will move in terms of manufacturing. And if there are some good histories, you can add them. So based on this knowledge and based on FMEA, you get a set of outputs like list of actions to prevent causes or detect failure mode, history of actions taken, and so on. So, okay, so let's go to the next slide. Yeah, so just give me 1 minute. I'll come back in a minute. Okay, we continue and maybe we go slightly faster. Am I audible, Sandeep?
Yes, sir. Yes, sir. You're audible.
Okay. So now we need to discuss when do we do FMEA, when do we do design FMEA, when do we do process FMEA. Obviously, before the design is finalized, before that design FMEA is done, and before the prototype is fully built, before that a process FMEA needs to be done. So design FMEA is done in the somewhere in between the design and process FMEA is done during the production. So once your concept is ready, you can do the design FMEA and then get the go ahead for design and complete the design. Similarly, when you are building a prototype, then you do process FMEA when the production is done as per the drawing. And then once the design FMEA is completed and the risk have been reduced, then you sign off and the mass production starts. So it says start early in process. It is complete by the time preliminary drawings are done, but before any tooling is initiated. So we need to reduce the number of risks through design FMEA. Similarly, process FMEA start as soon as the basic manufacturing message has been discussed. So for example, you have decided you'll do welding, you'll do forging, you'll do casting. Then as soon as you decide, you can start working on process FMEA. It is completed prior to finalizing the production plan and releasing for production. So design is done before the drawings are released. Design FMEA is done before the drawings are released, and process FMEA is done before the production plans are released. So let us see if you want to do FMEA in general, right? Whether it is design or process, we have to ask certain questions. like how can the design or the process service fail, right? So it can be design, it can be process, or it can be service. So when we do service, for example, we do consultancy, or I am a driver, or whatever work I'm doing where there is no input or output in terms of the components, but I'm giving my service, then you have to also do service FMEA. But here we are not talking about service FMEA. We are only talking about design FMEA and process FMEA with respect to the BAHA vehicle. So once you say that, okay, my design will fail in following area, then you have to say, in case it fails, what will be the effect and how serious is the effect? That means, will my vehicle stop? Will it meet an accident? Will it kill anyone? Will it kill the driver? Then you have to find out what is that effect and how serious it is. If it is going to lead to an accident, then the seriousness is high, and it may lead to some scratch or some noise, then the seriousness is less. So we'll see how do you quantify that seriousness. Then comes, what are the causes of failure? So now you understood where the failure is happening, how much failure is happening, what is the effect of that failure, and how serious that effect is. The next step is, yeah, it is very serious. Risk is very high. So how do you reduce this failure? To reduce that failure, you need to go to the root of the failure. That means you need to find out what is the cause of that failure. हमने मटेरियल गलत यूज किया इसलिए फेल हुआ, हमने वेल्डिंग गलत किया इसीलिए फेल हुआ. फॉर एग्जांपल यू आर मेकिंग अ रोल केज, तो मैंने वो रोल केज बनाते वक्त I have done the wrong welding, or my welding was improper, or I have used altogether wrong welding method. टिक वेल्डिंग यूज करना है कि मिग वेल्डिंग यूज करना है कि क्या करना है, वो मुझे समझ में नहीं आया. थर्ड, जो मैंने मटेरियल लिया था वो मटेरियल ही गलत था. सो व्हाट आर द कॉजेस ऑफ फेलियर इज व्हाट यू मस्ट फाइंड आउट. एंड वंस यू नो व्हाट इज द कॉज ऑफ दैट फेलियर, then you can then concentrate on that cause and eliminate the cause so that the failure doesn't happen again. Now, how likely the occurrence of failure? So ये जो failure हुआ है ये कितनी बार हुआ है? माने for example in field, if the crankshaft is failing of an engine and it frequently fails, that means the dealer बोलता है आज मेरे पास 10 गाड़ी आई जिसमें 10 गाड़ी में crankshaft fail हो गया. तो अगर crankshaft fail हो गया है, तो अगर 10 बार फेल हुआ है अलग अलग गाड़ी में, तो that means the occurrence of that failure is high. It is more serious, and we need to look into the statistical analysis that why it is failing again and again. And can we prevent the cause of failure? So it is not the effect which is important, it is the cause which is important if you want to reduce the failure or eliminate the failure. So get into the root of that, find out what is the cause of this failure, and try to eliminate the cause. And also try to find out what can I do to detect that cause. For example, in CNG, from the CNG cylinder or hCNG, from the hydrogen CNG cylinder, it is leaking. Then is it serious? Yes, it is serious. It can lead to fire. If somebody is smoking around, then it can lead to fire. That's why when we refill the CNG or hCNG, we ensure we cordon that area and ensure that no one smokes in that area. फिर भी एक दो बंदा मिल ही जाता है जो दूर कहाँ स्मोक करने आता है और गाड़ी के वहां खड़ा होके ही स्मोक करता है, तो इट्स वेरी डेंजरस. So we ensure that no one smokes around the CNG refilling station. Then, तो अगर वो लीक हो रहा है, then what are the causes of that leakage and what are the effect of that leakage? Again, leak हुआ, so it can lead to fire, and if it can lead to fire, then the risk is very high, right? And what are the causes of this leakage? So maybe you have used a spurious part, that means आपने जो wall किया है, use किया है वो second hand wall है, या कोई चोर बाजार से लेके आए हो, या उसका quality control नहीं है, उसके threading बराबर नहीं है, उसका fit बराबर नहीं है, because of which it is slipping and it is leaking from there. All that thing has to be checked. What are the causes, and then try to reduce that causes and find out how many times it is happening, and based on that prevent the failures, right? So the last question is, how can we minimize the risk of failure? मैं क्या design modification करूँ so that the failure reduces? So when you are doing design FMEA, just one minute. Hey, Sonal, please continue. Just 1 minute. Okay, fine. So how can we minimize the risk of failure is what you need to understand. And the failure can be minimized by changing the design. In design FMEA, the failure can be minimized by changing the design, by changing the material, and sometimes even by changing the assembly method and so on. Whereas in process FMEA, the production process has to be modified so that the failure doesn't happen, right? Okay. So this is what is the crux of FMEA. And now to do that, you have to first decide the boundary condition. So this is known as a block diagram. For example, you have an engine. Then, so when you want to do design FMEA of an engine, it is like Arjun is looking at the bird's eye. So for you, that bird is engine, or the bird is that entire vehicle, but you are only concentrating on the engine. So that becomes the bird's eye. Tomorrow, if you want to do design FMEA only of the CNG or hCNG cylinder, then that cylinder becomes the bird's eye. So what is that bird's eye? You have to make a block diagram and say, today I am going to do design FMEA of the CNG cylinder. Then that becomes my boundary condition. All others are interactions. So interaction can be physical, or energy can be transferred, or data can be transferred in case of software. Material can be transferred, like gas can come in, gas can go out. For example, in engine, we have 5 fluids: the air, the gas, that is CNG or hCNG gas, that is the fuel. Then there is coolant, there is lubricant, and there is an exhaust. So these are all different types of fluids. So this is called material, and the material is coming from one direction, going in. That means the fuel and the air is coming in one direction, and the exhaust is going out in the other direction. So again, so that is material. Similarly, data. If there is an ECU, then ECU will collect the data, the inputs through the sensor, and give the data, and use the logic and give command to the actuator to work according. So that is data. Energy, that means heat in, heat out, increase in temperature, reduction in temperature. All these are part of the energy. So you need to make the block diagram and decide, I will only work in this block diagram. I will do design FMEA only on this diagram, except the interaction. Interactions will be taken care, but no other physical part will be taken. That means if you are doing engine, so you are not worried about what will happen to the gearbox, or you are not worried about what will happen to the wheel, and so on. Okay, then comes the final design FMEA. To do that design FMEA, you have to use a particular table, a format. So this is a correct format. You will also get this format on the website of BAJA SAEINDIA, and different people use different format. I see many students, they put this severity, occurrence, and detection together, which is generally done repeated at the end, but not in between. So if you look at the sequence, first you find out what is the potential failure mode and what is the potential effect. So when I say there is a leakage, then leakage becomes a failure mode. And for example, you take a cylinder, hCNG cylinder, then the function of that cylinder is to retain the gases and give out to the engine as and when required, and ensure that there is no leakage. And then there are so many other things. There must not be any bursting of the cylinder. There must not be any leakage of the cylinder. There must not be any decay of cylinder, and so on. So you write down all those failure modes. That can be burst, there can be leakage, there can be deterioration. So these are all called failure mode. Then you ask, what is the effect on this? So leakage से क्या effect होगा? तो it can lead to fire, right? So then you put, and then say how severe it is. If it is going to lead to fire or loss of life, then severity number would be very high. So severity, occurrence, and detection, these are the three numbers which you have to quantify, and the quantification number varies between 1 and 10. It is never 0, right? So if you give up and said this is good for nothing, then also you don't give 0, you give 1, because finally the risk is decided based on the multiplication of severity, occurrence, and detection, and all these numbers are out of 10. So if the risk is very high, then it will be 10, 10, and 10. It becomes 1000. That means the maximum RPN, that is risk priority number, is 1000. And if there is no risk at all and everything is perfect design, then you can say severity, occurrence, and detection is 1, 1, and 1. So the multiplication of these three becomes 1. So the minimum risk priority number is 1 and the maximum risk priority number is 1000. And that is why you cannot put 0, because if you put 0 to any one number, whether it is severity, occurrence, or detection, then your RPM will always become 0. And you don't want that to happen. So you can give minimum 1 and not 0. That is what we tell to our judges also when they evaluate you. We tell the judges never give 0, give some number, between 1 and 10. Okay, so let's go ahead. So severity, occurrence, and detection, we already said if it is very severe, it can lead to a very harsh effect. Then severity is 10 or 9. And if it is just scratch or something, then the severity is 1 or 2. We'll see that through example. Similarly, occurrence, how many times that failure is occurring in the field on the same vehicle or on different vehicle, then occurrence number is 10 or 9. And if the failure doesn't happen, it is just an hypothetical thought that it may fail, then the number may be 1 and 2. Then what are the current design control, prevention, and detection? So when you do design control, for example, on the dashboard, you can see what is the pressure. For example, there is a lubricating oil and the lubricating oil leaks in the engine, then you will come to know on the dashboard that the pressure is going down. But if the lubricating oil is not leaking and everything is foolproof and well packed, then your lubricating oil pressure will remain constant. If the lubricating oil pressure remains constant, you will get a green signal on your dashboard. That means your oil system is perfect. Nothing to worry. Lubrication is taking place. But day the leakage starts, then the pressure will come down. The lubricating oil will get leaked. And then you will come to know that the pressure has gone down. So the lubrication will not take place and it will show red. So this is how you must be able to detect. So detect in terms of control prevention and detect in terms of control detection. So if you are able to detect it, then it is good. But even after detecting, if you are not able to prevent it, then it is not good. So you have to have both the solution, how to detect first, and then based on the detection, how to prevent. And that will decide the detection seriousness. And then you combine them. So when you come for the first time, teams make a lot of mistakes. When they come for the first time on 19th or 20th July, they fill up the entire form. You must not fill up the entire form. The last 5 columns has to be kept blank. Why? Because the last 5 columns are filled up only after the prototype is made and some vehicle is running for some hours or some kilometer. And based on that, the severity, occurrence, and detection are remapped. That is known as action results. So when you come for the first time at the initial design in DR1, last 5 columns are not filled. And when the entire exercise is over, when your vehicle tested the vehicle for 100 kilometers, then you fill up the last 5 columns. Is it clear? Okay. So there are certain guidelines. So for example, last year we had said minimum 2 number of items to be taken for hBAJA teams, or minimum 5 number of sub items to be taken. These items are compulsory, these items are not compulsory, and so on. So all these design guidelines or design FMEA guidelines will be given to you, and which component or which assembly or whether the entire vehicle needs to undergo design FMEA can be decided in advance and given to the team. Okay. So the same thing which I explained you in the earlier slide, that is this, the same thing is being repeated here, but in a more systematic way. List all the function, list all failure modes, consider the effect if above failure mode happens, look possible for causes and consequences, assess the frequency of the occurrence, assess the severity of the effect, assess the possibility of the failure being detected, calculate the risk priority number, recommend improvements, define the responsibility and time. So once you recommend, okay, we will do the following test, we'll run the vehicle for 100 kilometers and then decide what are the failure and accordingly make the design modification. Then that is known as design responsibility and time frame. And then based on that, you can reevaluate the risk priority number. Okay. So we are halfway through and the time is 2:46. So we'll have to move fast. So the same thing here, the column is given, start from the left-hand side of the table and move towards the right hand, except the last 5 columns. So now how do you do the rating? There are 3 ratings: occurrence, severity, and detection. So let's start with occurrence. How many times the failure is happening? If the failure happens 100 per 1000, then the ranking is 10. And the failure happens 0.01 per 1000 vehicle, then the occurrence table 1 is 1. So 1 means very less failure happening again and again. 10 means failures are happening again and again, and that is 10% of the total product. Okay. Then comes the severity. How severe is the effect? So if it is loss of life, it is 10. If it is not meeting the compliance of the government regulations, like emission norms, noise norms, then the number will be still 10. Yes. So if the accident takes place or you are not meeting the government compliance or government regulation like BS6 emission norm or pass by noise norm or it is not giving the required power, then your severity is 10. And if it is not giving the warning, it is 10. If it gives the warning, like I said, lubricating oil pressure is high and it shows red, then the driver knows something is wrong. Hello, please don't talk in between. Please don't talk in between. Okay, fine. So if it gives a warning, then severity is 9. If it does not give the warning, severity is 10. So on the dashboard, if it gives warning, then it is 9. And if it is not giving warning at all, and if it suddenly fails and I don't even know when I'm driving, then it is 9. So and so on. Okay. And then you will see that if the customer is not happy, then the number is down. If there is a squeak, rattle, or fish and finish, then the number is 4 or 3 and so on. And at the end, if you are not finding any effect at all, then the number is 1 and never 0. The third is detection. How do you ensure that how many times this failure is happening? For example, you launch a vehicle in the market and you have sold 200 vehicles. Now in this 200 vehicle, if the failure is happening, how that failure? So that you have to find out where that failure is and what is the likelihood that your design control will control it, right? For example, if you have a leak check and you find that something is leaking, you can control it. Similarly, here you must be able to find out what are the likelihood of detection by design control. So I told you that severity, occurrence, and detection, all 3 needs to be multiplied all the times. And based on that, what you get is RPN number, risk priority number. Higher the number, higher is the risk. Lower the number, lower is the risk. And generally, the top 20% of the failures is something which we need to relook into. Okay, so these are some examples of design FMEA. I have ensured that they are not related to hCNG cylinder or hCNG fuel injection kit. They are just suspension, steering, brake related. Just for an example for you, I want you guys to do design FMEA of hCNG kit and not anybody else, right? So here we have given example like systems of roll cage, steering, brake, transmission, and then what type of roll cage structure you are using, and whether it fails in bending or braking, what are the causes, what are the effect, and what is the SOD, severity, occurrence, detection, you have to find out. So one has done that exercise. Another example of design FMEA, almost similar, only the color combination is different. Okay. So that is all about design FMEA. Design FMEA tells you at the design stage itself what are the probable failure, and you ensure to make a design foolproof with all these things. So once your prototype is ready, so your vehicle BAJA buggy is ready, then it's time to do design validation plan. So what does the design validation plan teach you? Are we building it right? Again, at some intermediate step, if we check whether everything is going in the right direction, major cost of project are incurred in early design stages. So in early design, there is some cost of project incurred. The cost of fixing a design and faulty decisions at larger stage is exponentially greater than an earlier stage. So we have to find out the cost of fixing the design. And the last one is early involvement of CFT. CFT stands for cross-functional team. So in office also, we work in a cross-functional team and then give the output. So early involvement of CFT in product development saves time and money over product life cycle. Okay. So validation means a documented act of proving that any procedure, process, equipment, material, activity of or system actually leads to expected result. And the design validation means establishing by objective evidence that the device specification conform to user need and intended uses. So it includes the software validation and risk analysis. The validation must be documented in design validation plan and so on. So under design validation, we have different process: validation plan, validation review, validation method, validation report. So here you can see all this validation in design, validation in process, validation in output, and so on, right? So this is how design, and it will also give you the difference between validation and verification. For verification, one may not go to all the countries and do the verification, or somebody can do validation for you, whether they are in India or they are abroad, and they have similar inputs, then you can use that data. Right. So design validation is the next step to design FMEA. So you start with product concept form, then you do design FMEA, then you make drawings, and then you work on design FMEA, and then after design FMEA, find out what are the outputs, and then work further on it. So depending upon RPA and design FMEA, the components are arranged in DVP. It contains all the information regarding the acceptance criteria, responsible person or team, and type of test, and start and finish date. So you have to collect a lot of data and analyze them. Okay. So these are some of the examples of validation method: worst case analysis, fault tree analysis, and so on. So you also need to do a product design validation. That means you think of the validation at a very early age, and then conduct design review and design requirement analysis across the teams. Build one or several production-like prototype, also known but prototype. Perform design verification testing, and evaluate the evaluate and verify prototype performance. So you make a vehicle, take it to the outskirts of the city, where you have a torture track, and run it for 100 kilometers. And after 100 kilometers, come back and check what are the components which has failed. And if those components are there in design FMEA, accordingly, the numbers would change. So in short, design requirement analysis, that is customer's viewpoint, testing, knowledge, and design analysis will enhance the knowledge base at Nemtech. The last few slides. So we generally use V type of flow, that is in electronics especially. We first find out what is the voice of customer, what are the various regulation and business needs, and then based on that you finalize your design and do the validation. Right. So this is similar to design FMEA. This is the DBPNR template. So here also you have to fill up the college name and other thing. Sometimes the judges will get all these ready-made. So somebody has already done it for them and so on. So here also DBPR template is also there. Okay. And these are some examples of design validation plan where students have done. So in conclusion, I would like to say that the output of compilation of failure. So at the end of every event, you sit down and do a lesson learned. And lesson learned has two words: things gone wrong, things gone right. So under things gone wrong, what has gone wrong and what can we do to reduce it? And how do we ensure that the repetition doesn't take place? Then output of lesson learned is input to design FMEA. So design FMEA, design का जो input है, output है, that will become DVP. Output of revised DFMEA is input to calendar to clear technical inspection and win dynamic events. So that's all from my side. I hope it was interesting. I have not told you anything about CNG engine or CNG kit, but you can do design FMEA related to that and we can review it. So that's all from my side. Thank you very much.
Thank you, sir. Team, if you have any questions, please you can unmute yourself and ask the question, or you can drop your questions in the chat box also. Anyone have questions? Please ask.
If there are no questions, thank you very much. We are just completed on time. It's 3 o'clock. So it is advisable to do design FMEA of the engine as a whole. It is advisable to design FMEA of the cylinder as a whole, the storage cylinder. And it is also advisable to do design FMEA of the connection between the cylinder and the engine. Okay. Okay, Sandeep.
Yes, sir.
Thank you. Thank you very much.
Thank you, sir. Thank you.
Shall I take leave?
Yes, sir. Yes, sir. Thank you.
Yes, sir. Thank you, sir.
Yeah. Okay.
Team, we have a next session of testing and validation of hCNG vehicle by Dr. Manish Jaiswal. So he will be joining in 5 minutes. So we are waiting for him. So please wait. If you have any questions regarding any sessions we have completed yet, so you can directly message on the group or you can directly text us. We will send that questions to individual speakers and we will get back to you with the answers. So team, please be here. Speaker is joining in 2 minutes. Good afternoon, Manish sir.
Good afternoon, sir.
Uh,
Hello.
Hello, Manish sir. Yes, sir. You're audible, sir. Yes. Yeah. Sandeep, you can start. Sir, we can start.
Yes.
Yeah, Sandeep, you can start, please.
Yes, sir. It's my pleasure to welcome Dr. Manish Jaiswal, Director of Netrax, with a PhD from IIT Bombay and impressive career spanning of over 20 years in electric mobility, R&D, and product involvement. Dr. Jaiswal brings a wealth of knowledge and visionary leadership to the field. We are truly privileged to have you with us today for this workshop. Over to you, sir.
I think we have the basic information wrong. I'm not from IIT Mumbai. I did from Loughborough, UK. But anyway, let's come to the top. I've been told that this is a workshop for high students who are freshly coming in this lab. So, what I'm going to talk about today is a bit of fundamentals. So, in case you have already been aware of all this information, so repeat stuff for you. I believe a lot of students in this workshop maybe coming to BAHA, particularly hydrogen BAHA for the first time. So maybe for them it is some sort of awareness about hydrogen BAHA and how it stacks up as compared to other BAHA. So we will say we will have a slide deck. I will just quickly share my screen. Meanwhile, if one of you could brief me what all things have been covered so far, so at least I have a fair bit of understanding where we are in terms of overall flow of the workshop, so that at least I get a perspective and don't just jump into something without knowing the right context.
Sandeep, you can proceed.
Yeah.
Just a few
So we
minutes
have
so that at least I am aware of.
Yes, sir. So like we have completed the topic of basic of hCNG technology and vehicle adaptability, hCNG bifuel engine and control systems, do's and don'ts, hCNG injection kit components and integration, DFMEA DVP for engine and hCNG kit. We have completed these all topics, sir.
Okay. So we already completed lot of stuff. So maybe then in that case, some of the information which I'm going to talk maybe a bit of a repeat for many of the students, but it doesn't hurt if you get a fresh perspective from about BAHA. So anyway, let's understand few fundamentals or few say a bit of a background that BAHA was started at Nitrax in 2007. It is almost 18 years of long journey since it was started.
Sorry to
and
disturb, sir. Your screen is not visible, sir.
Oh, is it not visible? I was sharing it. Let me do it once again.
Yes, sir.
Let me know once it is visible now. Is it
No,
visible
sir,
or
not.
still not visible?
No, not visible,
No?
sir. No,
Not
sir.
visible, sir.
Okay, I think we need to try some other option. Let me see if that works. Is it visible?
No, sir, not yet. It's
Oh,
not
no.
visible.
Okay. And let me
Sandeep,
try
you can
one
also
more
confirm.
time. No, why it is not. I've been sharing my screen.
Yes, now it's visible, sir.
Is visible? Okay.
Yes,
So
now it's
maybe
visible,
after
sir.
repeated try, it works. I haven't done anything clever. It is just repetition. Okay. So yeah, I was talking about bit of a background of BAHA that BAHA started in the year 2007 at Nitrax. Nitrax is literally the place where it was born, and not only mechanical BAHA, which started in 2007, later electric BAHA, and also hydrogen BAHA, which started originally as CNG BAHA, and now this year it got blended with 5% hydrogen, so it becomes hCNG BAHA. So that also got started at Nitrax. So we are literally the place where all these three events from BAHA family were started, and we have seen the growth of the BAHA and it getting spread to all corners of the country with newer teams coming with newer energy and transition of the old students of BAHA into alumni. So we have seen the transition. So that gives us a confidence that yes, the students who are now freshly coming into the BAHA maybe going through the same phase of journey. So let's quickly look into what is BAHA SAE India. Uh, it is a engineering society, SAE India, and which has taken the ownership of BAHA, which was originally a US contest, but from last 18 years, it has been formally embedded into an Indian engineering ecosystem. And it happens in the month of, let's say, January, where the actual event happened, but a year preceding to that event, a lot of other activities take place. One of that is a workshop, and then obviously the virtual, say, designed, and then virtual rounds, and finally the fabrication, and eventually the test and engineering. So let's say what is going on in terms of overall BAHA scene. We have mechanical BAHA, which was started in 2007. Then we got into electric BAHA. This was the first time any BAHA had an electric propulsion system all across the world. So India had a pioneering role to play here, where the electric BAHA was introduced for the first time. Similar is the case of hBAHA, where we took a say pioneering initiative that let's introduce this hBAHA as well, and then also autonomous BAHA. So these are, say, additions of the original BAHA, so that BAHA vehicle as a larger concept still was intact, and the propulsion system got changed. Few more things were introduced in autonomous BAHA in form of what all testing and validation used to need to happen, which is pretty different from the conventional BAHA, or let's say eBAHA or hBAHA. So hBAHA overall is an extension of mBAHA. You won't see a very different type of vehicle structures. You won't see a very different type of test and validation, or a very different type of, let's say, design contest, but it is still has its own charm in terms of what all technology you get exposed to, what are the learnings you need to acquire as a student. So we will talk on all those fronts today. Okay, so let's quickly look into mBAHA so that it sets the right context for you as we move along. So mBAHA is basically a mechanical BAHA. Many of you may have already participated in either in your initial years, or you must be well aware of it. But let's quickly look into what all it constitutes. It is basically a mechanical design, durability, and vehicle dynamics contest, which involves design evaluation, and then various type of maneuvers like acceleration, maneuverability, hill climb, endurance race, which goes for 4 hours on the last day, and based on which the final results are announced. And then there are salient learnings like CAD, CAE, fabrication, testing, real world engineering, project management, innovation, uh, costing, presentation, teamwork, and all of
Hello,
that.
sir.
Okay, so key learning, as you
Sir,
can easily
so
imagine,
sorry to
it goes
interrupt.
from concept to hello.
Yes, sir. Sorry to interrupt, but your screen is not like changing, sir. It has been stuck.
It is stuck.
Yes, sir.
Okay, let's do one thing. I think there is some disruption, so I will stop sharing. I will quickly pass on the PPT through WhatsApp. Uh, so that at least you can show it from your end, and in that way we don't end up into this type of glitchy situation.
Yes, sir. Yes.
Is that okay?
Yes, sir. Yes, sir. Yes. You can send me the PPT. I will share the screen.
Yeah, so give me a minute. I will quickly do that transfer. I was hoping this whole thing will work. I have a pretty good internet at my place, but somehow it's not working. Rameshwaram, I am doing this transfer to you.
Okay.
Just, it will reach you in few seconds. Hmm.
Okay, sir. 1 minute. I will check.
Yeah, it is being transferred to you. It is hardly 2 MB file. Did you got it? I should have done that earlier. I was thinking it will go smoothly. Let me know once you receive it and we can have it beamed again.
Sir, it's received. I will share the screen.
Yeah. Good. Yeah, let's go to slide 5, the place where, yeah, the next one. Yes, this one. Yeah, so can you go to mechanical BAHA is a step before?
Yes.
Yeah, yeah. So I was talking about setting the context in terms of how mechanical BAHA takes into account the testing and other stuff. So we, as we were talking, we had the overall design evaluation and then various type of maneuvering, whether it is acceleration, maneuverability, hill climb, endurance race, and then you have various aspects of the contest, whether it is CAD, CAE, fabrication, testing, project management, teamwork, costing, innovation, and all of that. What are the key learning? This is very important part. What are we exposing students to? You basically get exposed to uh, doing a vehicle right from concept to execution. So in between, whatever uh, is supposed to happen in industry is what you are basically exposed to, right from design, then validation, then various calculations, the CAD part, the drawing part, and then how do you package it in all into one system level assembly, and then taking care of the manufacturability, the costing part, and then finally the testing, prototyping, testing, and then final say validation. And that is what after that you come to the place where the whole testing or the contest takes place, and then you present that thing to the judges by having your vehicle performed on the real ground, as well as showing your design to the jury as well. Okay. Now, while doing it, lot of standards are inbuilt, which I don't need to cover in this, but at least it gives you a confidence that whatever you are doing is not just in isolation, that we are asking you to make some buggy. It complies to certain standards, so that part all is also something which you are exposed to. And once you go to the industry, you need to learn those standards in lot more stringent ways and ensure that whatever part of the system you are working in, you comply to the standards, you comply to the global best practices, so that you don't end up into making something which ends into trouble when it comes to certification or homologation or not meeting the set standards by the various regulatory bodies. Okay, that part is important. Coming from a test agency like us, who are dealing into this area all the time, we have to ensure that when a vehicle is homologated or a certain part of say testing happens, it complies to a standard, and people are doing say a product development or product fine tuning based on those standards. Okay, let's come to the next slide. Hello, can we come to the next slide? I think. Yeah. Now the next one is hBAJA. So sorry, you are jumping too fast. So can you go to the previous one, the hBAJA, when we were talking about hBAJA? Yeah, 2 slides by, yeah, hBAJA. So in hBAJA, it more or less the structure was carried forward from mechanical BAJA, but then it was a electric propulsion. So it means it has a BLDC motor, 48 volt lithium ion battery. Rest everything stays same, and the key learning which student has to acquire is on the electric propulsion, the battery management system, the wiring harness, the drivetrain integration, as well as overall exposure of the EV development cycle. Okay. Then as you understand, electric vehicle is the future, and a lot say type of vehicles are getting converted into electric. It is not just electric scooters, but even bigger vehicles like construction vehicles, the tractors, the buses, the heavy duty haulage vehicles. All of them are eventually going to get converted into electric powertrain. So there is a huge future for students when it comes to electric mobility. Okay, now let's go to the next one, the hydrogen BAJA. This is what this event is all about. So let's try to understand where we are in hydrogen BAJA. Can we go to the next slide, hydrogen BAJA? Maybe there is a phase lag between what you are presenting and what I am seeing.
Sir, I'm on that slide only, hydrogen bar slide.
Issue. Hello.
Hello.
Yeah. So
yes, sir, I'm that slide only.
Yeah, I can see it. Yeah. So now, when it comes to hydrogen BAJA, the structure again stays same as compared to mechanical BAJA and electric BAJA. But what changes is the fuel and the engine. Okay, so it uses a mix of CNG and hydrogen. We are not talking about pure hydrogen as a fuel. That future is still some distance away. What we are talking about is a mix of hydrogen and CNG. Currently, we were at 5% hydrogen level, and that is what we want to eventually increase to 18%. So what are we asking students to innovate? It is basically the fuel injection, the combustion optimization, the safety system for hydrogen handling. Now, hydrogen storage is a very critical area, because you mess it there, then you will have a serious safety say problem. So hydrogen handling, hydrogen storage is a critical area, and that is what we want to. I think can others switch off their microphone? I can see a lot of background noise. I can hear. Can all of you switch off your mic? Yes. So what are the practical learnings for students? It is basically the alternate fuels, the understanding of India's larger hydrogen mobility mission, and then obviously the skills on the engine tuning and fuel system integration. So this is especially useful for people who still loves IC engine, and I am one of them. You have to go for the next gen technology, which is taking away the fuel in form of petrol and diesel and moving towards, let's say, alternate form of fuel, which in this case is CNG plus hydrogen. In future, it will be complete hydrogen. We are also talking about flex fuels where ethanol is getting blended. So this is a say a transition from mechanical Baha where the fuel is still conventional, engine is still there. We are not replacing the drivetrain, but yes, we are taking you from like conventional fuel to a futuristic fuel, which is hydrogen. Okay, so we are still retaining the IC engine. Lot of learnings which goes with the engine, not only engine but its all its support systems as well, whether it is fuel or storage or any other parts related to fuel injection or blending, all of that you still learn while doing the hydrogen Baha. And especially that skill is useful because when you do the testing and validation, you need to be aware of what all the safety criterias when it comes to testing a hydrogen blended vehicle. Okay, uh, there are finer nuances which you will learn as you move into making this. So can we go to the next slide quickly? Autonomous Baha, and then we come straight to. Yeah. So in a very short, we are talking about. No, I think you have jumped a slide. Yeah. Can you stick with the hydrogen slide, please? Sorry, a Baha slide. Yeah. So now you can see the autonomous Baha slide. We are talking about autonomous Baha where basically you are learning about the various electronics and sensors, be it LiDAR, GPUs, IMU, cameras. Then you have various software or algorithms like path planning, obstacle avoidance. So these are type of things which you need to bring on board when you are moving from, let's say, a conventional mechanical driven vehicle to a vehicle where the control is partially given to the system. Okay, so it emphasizes on the real-time perception, sensor fusion, vehicle control logic. These are again futuristic technology where which we want to be exposed to students, and we want to bring in newer stream of students here, be it, let's say, computer science students or embedded say students, be it electronics or any other form of let's say circuit engineering, so that they get exposed to vehicle building at a very young age while they are in colleges, and then the hands-on learning goes in form of not only a understanding of the larger ADAS concept, but about the various electronics and sensors and how the algorithm plays out in a complex environment. Okay, so overall, I have touched base on all four say Baha types, and let's come to the next slide, which is going little more into the hydrogen Baha side. Yeah. Yeah. So let's say what is hydrogen as a larger say mission when it comes to Indian ecosystem. In the year 2021, the National Hydrogen Green Mission was launched with a outlay of over close to 20,000 crores. And the larger idea was India needs to become a global hub for hydrogen production and export. So it is not just talking about hydrogen, usage of hydrogen in form of mobility, but it also talks about in larger sense about hydrogen production. And the very fundamental reason why we are talking about hydrogen is our concern for the environment, the type of emissions which we are seeing, especially in urban, say, clusters, our metros and all the urban areas where you have a huge concern about emissions coming from overall transport sector. It constitutes roughly 1/3 of the overall, say, carbon emission which we have in the country. And then automotive may be still in single digit, but overall it has a a larger impact, at least in the urban areas, because that is where you see the vehicles moving. If you are outside city, you may not see, you may not have that sort of an impact, but right in the middle of the city, the transport as a entity is a big factor for larger carbon emissions. So now when it comes to the our overall mobility players, our big players like Ashok Leyland, Tata Motors, and few more like Cummins and all, they are investing heavily into hydrogen as a mobility option for automotive. And then we certainly need lot and lot of skilled manpower to go and support this sector, and that is why we want to train young students like you so that you can become the future, say, resources for taking this larger mission, not only at a national stage but also at international stage. So I hope that sets the context for you why we are talking about something which is not so prominent at this stage, that you won't see so many of hydrogen vehicles getting launched. That future is still some distance away, but we want to train you in a futuristic technology so that once you reaches a certain stage in your career, you can become the pillar on which our green hydrogen mission will rise, and we will have a larger ecosystem where very active engineering is happening in India. Okay, so let's go to the next slide. Okay, so let's talk purely on what is hydrogen BAHA. So it was launched in 2024. I have anyway covered a lot of aspect why we wanted to do hydrogen BAHA in India. But as a concept, it is started with CNG in the year 2024. It was launched as a CNG BAHA, not as a hydrogen BAHA. And I think in this year we have seen the shift. The program was again started in nitrax, where Honorable Minister Mr. Gadkari came and he did the inauguration of hydrogen BAHA in India. So, and he was very supportive of this event. He said, yes, this is in the right direction. He flew all the way to Natrax to ensure that he motivates the students. And we have a very important initiative kick-started by Gadkari Sahab in Gadkari Sahab presence, and we hope that that acts as an encouragement for not only engineering students but their say colleges who have to support this initiative and allow and provide say guidance to the student communities, because it is also a learning for our academicians who may not have worked at all in hydrogen area. They will acquire some new learning, some new exposure, and that sort of lays the foundation for maybe in future new courses getting introduced in our colleges for related with hydrogen as a fuel option. So it also silently pushes the subject in academia and tries to bring it in the streamline, because I don't think any engineering colleges who may be teaching automotive subjects may have hydrogen BAHA aspect covered in their course curriculum. So it also encourages the academia to take the subject little more seriously and maybe at least offer some courses or some say small chapters about hydrogen as a mobility option. So let's go to the next slide. That basically gives you a flavor of why we are so hell-bent on taking hydrogen BAHA as a serious engineering contest. Now, this is the same thing which I told earlier. It reduces carbon emission as compared to petrol, diesel. You don't need to, oversell it. It is pretty much understandable by anybody that why we are doing it from the purely from the environment perspective. Okay, let's go to the next slide. Yeah, so what is the engine we are talking about? So the engine is basically provided by Greaves Cotton. It is a bi-fuel, four-stroke, water-cooled, electronically controlled engine. Bi-fuel, why? Because we are talking about a conventional fuel, CNG mixed with, let's say, 5 to 18% of hydrogen. Then the team uses modified engine, but obviously they have to design, fabricate the rest of the structure. It has ECU control injection, then CNG filter, temperature sensors, then controlled emission setup, detailed exhaust and fuel routing. So we are giving you the engine, which is the heart of any vehicle, to you, so that you don't have to at least worry about the engine. That will be a common thing as it always was in mechanical BAHA. But yes, you need to still understand its fundamentals. So I will still encourage the students who are participating that please go and get yourself trained in the fundamentals of engine technology. Okay, even though you may not be making engines, you may not be designing it, but it is always good to learn about it, how it works, what is the various subsystems, how the combustion takes place, what are the say various types of performance criteria, be it related to torque or power, or say wall trains, so that you expose yourself into the fundamentals of engines, which is a very important thing for any student to learn. Okay, let's go to the next slide. It is still waiting to come in my, yeah. So we will not spend much. This is the same thing we have been talking about earlier. We want to increase the hydrogen adaptation, so that is why we are doing it. Go to the next slide, please. Yeah. Yeah, now we will quickly look into the comparison part, how it stacks up as compared to various other BAHAs. So you can understand when it comes to fuel type, the mBAHA is basically petrol, the E is BAHA is battery, the hABAHA is also electric BAHA, which is now adapted as an autonomous BAHA. So powertrain stays as electric, and then we have hBAHA, which is a CNG BAHA, again a IC engine. So in four different types of BAHA, you can understand two are driven by electric motors and two are driven by IC engine. So it is a healthy distribution which we have kept, that we are keeping a balance of both the world. On one side, we have two different fuels, petrol and hCNG. On the other hand, we have the same IC engine. And similarly, in the other two, which is electric and autonomous, we have an electric propulsion, but then the control in one case is with the driver, and in second case it is partially given to the controller. So emission is high in mBAHA, in hBAHA is very low, and at least in eBAHA and aBAHA the tailpipe emission does not exist, so that is why we call it zero. But then you have other form of emission when it comes to, let's say, the tire emission or any other say non tailpipe emission. Technical complexity Even though I may not agree entirely, but yes, hBAJA purely from a fabrication perspective, it is a medium high category because we are not asking you to fabricate the engine. We are more or less giving you the engine. The rest of the structure stays same. Cost is moderate. Learning outcome is hydrogen integration with the other systems. Okay, and then the biggest advantage here is on the green mobility relevance. So why we are doing it, we have already talked about it as compared to any other say form of say yes, BAHA. This ranks very high when it comes to green mobility. As we all know, hydrogen is considered or billed as the cleanest fuel. And with the abundance in India, at least, where we don't have to rely on, say, external ecosystems. For example, if we go talk about electric mobility, we still have a huge dependence on raw material, whether it is lithium or rare earth material. So we have huge dependence on outside. Similarly, we have huge dependence on oil for a conventional vehicle like petrol or diesel, whereas for hydrogen we are more or less in a position to become self-reliant in future. So that is what stands out in case of hydrogen as compared to any other mobility, that we don't have to be dependent on external players. And as you if you are watching the international situation, you must have made it out yourself that the world is always on the brink of a some of a crisis. What we have seen in last few weeks, whether it is the war going on between Ukraine or Russia, or now with Israel and Iran, uh, the crisis in automotive is just always some distance away. So let's say if the war would have escalated, we never know how the impact would have been on the conventional fuel, oils, and all of that. Right. So in a larger sense, yes, if we are talking about self-reliance, energy dependence, then hydrogen is the fuel for future, and that should act as an encouragement for you to keep working in this area. Okay, let's go to the next slide. Yeah, so let's talk about now. We are talking now, coming towards the end of that, and then we will leave the deck open for Q&A. So, how the evaluation of hydrogen BAHA happens? So, as, it happens in at any other BAHA, we have virtual round. Where we to the field when you all will come to let's say Natrax for or let's say you come to the field, what all you have to do. So it starts with the static events followed by the dynamic events. So in static you have engineering design events, whether it is design report, design specification sheet, comparison sheet, design validation plan, or cost event. Then you have to go for the cost report template. And then similarly in other static events you have sales pitch, the manufacturing excellence, the innovation part, the CAE part. These all are anyway happening from many years, with little bit addition every time. So there is nothing new when it comes to hydrogen power. You still have to go through the same stuff. But yes, as I was talking earlier, you still need to learn the concept, because unless you learn that concept, you won't be able to present it with a lot more confidence to the jury, because there could be a lot of questions asked by jury which will try to gauge your overall understanding of hydrogen BAHA as a concept. Okay, why hydrogen, how it works, what are the finer differences between in IC engine between petrol, diesel to hydrogen. So any judge can ask you. So it is always good for students to go and improve their fundamentals, make themselves aware of how hydrogen and CNG as a system works, and what all are its differences as compared to other form of fuel, so that it gives you a good preparation not only for your future but also in the context. Now when it comes to the dynamic events, it is the same set of events. We have acceleration, then traction event, maneuverability, endurance, performance, and then efficiency event. So these are pretty much similar to what we do in mechanical BAHA, but yes, the track may be slightly different as compared to mechanical BAHA, which is a lot more rugged event as compared to hydrogen BAHA. So the endurance track may not be as rigorous or as say challenging as you see in mechanical BAHA, where let's say vehicle has a lot more factor of safety or cushion, whereas in hydrogen BAHA, since we are talking about a storage tank which needs to be guarded, we don't have that level of complexity, even though the event names are same. But when it comes to the maneuverability, endurance, performance, it is a tad lower as compared to mechanical BAHA. Let's go to the next slide. Okay. Yeah, so let's also try to compare the overall BAHA and how what all things are not applicable in hydrogen BAHA. So you can see that most of the things you see in mechanical BAHA and e-BAHA are there in hBAHA as well. Some things which are not there, like specialty events, the mathwork simulation, these are not there, but at some point they may also come there. Then uh, can you go back to the last slide? Sorry. Yeah, so this table gives you more or less a comparison of that hBAHA in its entirety does not deviate much from mechanical BAHA and e-BAHA, but yes, few things are not there like simulation and let's say specialty event, but more or less everything else stays same. Last year we did one special thing in mechanical category BAHA at Natrax, and that was a virtual sync event. Now, if you are not aware, what we did was we let students do a actual testing on a virtual track, which is a digital replica of the actual track. So, what we have seen over the years that when students go into the design, they don't really make the same product which they design. So when it comes to production vehicle or production prototype, it deviates from their actual say CAE say prototype. So to bridge the gap, what we decided, let's bring a virtual event which forces students to make their physical prototype as near to the virtual prototype. So it means that we need to do a actual validation of physical versus virtual. So that was a contest which was launched this year, where we created a specially built track at Nitrax, and the digital replica of the same was given to students. Now students have to do a virtual validation on the virtual track, come up with the results, and then build the vehicle with the same design, come at Nitrax, do a physical test, and then match the two results. Okay, and if the result come close, it means your virtual engineering lessons are at a high level where you are almost ready for the physical to virtual validation. There is a lot more advanced engineering which goes into it to ensure that your actual prototype vehicle is more or less in sync with the designed prototype or the virtual prototype in terms of its mass distribution, in terms of its overall dimension, in terms of its performances, so that whatever you design is what you actually test on the ground. Okay, so we may open up that at some stage for hydrogen BAHA as well, so that you are exposed to not only engineering but also to virtual engineering in a more serious way. Okay, let's go to the next slide. Now let's quickly once again look into the advantages of hBAJA. We have been talking about it from last more than half an hour, but to summarize it, we have a deep understanding of alternate fuels. We have integration of electronics and instrumentation. We have real world problem solving around fuel economy, emissions, and safety. We have exposure to future relevant technology, hydrogen, which in this case is hydrogen vehicle, and then the salient other parts like internship, industry mentorship, and the design documentation is skill, and then obviously the design and fabrication of a ATV, which is the core of BAJA, is pretty much what you overall learn as a student through this hBAJA. So, so this is, I think, all about today's presentation. We are talking about the same thing again in the last slide. So we want to give you a lot of engineering skills, soft skills, and train you well for the industry. Yeah. Do we have? Yeah. Can we go to the last? I think this is what. So yes, this is a snapshot of last year. Say BAJA is hydrogen BAJA vehicles. So we are trying to create a new legacy through a future fuel vehicle. So that's all I have to talk about in today's presentation. So now we will have few minutes quickly for any query if you have or any other comments which you want to offer. We can spend maybe 5 to 6 minutes there. Do we have time for a few minutes for Q&A, or we are
Yes, sir.
done with the?
Yes, sir. We are
We have
having
time,
a
sir.
Q&A session, sir.
Yeah, so let's spend maybe 5 to 6 minutes so that we give others a chance to uh, discuss anything which is of common interest.
Team,
Okay.
if you have any questions, you can ask, unmute yourself, you can ask, or you can drop the questions in the chat box.
Okay, I think nobody is looking like interested to ask questions. But I
Team,
believe
sir, there is one question, I guess. So where to
There is a
get
question.
training?
Where to get training in hBAJA engine technology?
yeah, it's a good question. I think at present, all you need to do is there is a lot of material available in internet, and you need to self-learn, but we need to also take this as a feedback to see if we can offer students some additional sessions on hydrogen BAJA engine with some industry experts. So let's take it as a feedback. At present, I would say encourage you to go and try to download materials from web or from some publication. But yes, we can take it as a feedback to see if we can organize some sessions for you.
So there's another question. What is traction event?
The traction event is basically so let's understand what is the word traction. Traction is basically the gripping of the tire on the road. Okay, So we try to test vehicles in a dynamic condition if it really holds the ground or not. So we exposes you to certain maneuvers, and you have to drive your vehicle. If it sort of clears it without slipping, then that you get a point. So that is what is the traction event in short. Okay. Maybe I don't have a video, otherwise I would have shown you. Maybe somebody can take a feedback and show them some video so that they understand what we are talking about. Can we do it?
Yes, sir. Yes, sir. We
Yes, we
can
have a
send
question.
him the videos of traction event.
Mhm.
Like same question
So
in respect to that only, sir. So
yeah,
you
yeah.
mentioned
So I
traction
think
event. It is
once you show the video, that will give you a clarity. It is more or less the same stuff, but yes, the rigor of suspension and traction in mechanical is slightly on a higher side as compared to hCNG. So, but the concept is still same. Maybe once you see the video, you can understand it better.
okay, sir. Teams, any more questions? You can just post or you can speak up using unmute yourself.
Yeah. But yes,
So there's a question. Is it
is it
feasible
feasible
to
to
incorporate?
incorporate some basic yet major ADAS system to hBAJA? I don't think we have created a plan like that we will have a mix of ADAS and hydrogen BAJA in our contest. This you can certainly do at engineering college level. Let's say if you want to experiment once you have made a hydrogen BAJA to bring ADAS features. But at present, I don't see there is a plan to integrate both of them and create a contest. But yes, that sounds like a good feedback for us to see if that is possible in future or not. Okay.
Teams, any more questions, or we can wrap the session?
Yes, I think my apology. I could not come with that video. Otherwise, we could have made it little more interesting in showing you the attraction event. But I believe somebody from our alumni community will take that action and show it to you. So yes, I will log out from here. Thanks once again for listening to the entire 40 minutes of conversation patiently. I wish you all the best, and I hope you will take it as a motivation to go a little more deeper into this area and acquire new learnings and come to the real contest in a better, informed way. And take important steps to not only build vehicle but also learn the larger future technology in form of a hydrogen enabled vehicle. So thanks once again for the organizers for conducting this session, and best of luck to all the students. Thank you.
Thank you, sir. Thank you, sir, for the joining and this insightful session for you. And thank you, sir. Thank you, sir.
Thank you. Bye.
Thank you, sir.
Team, so we have covered all the session for today. So tomorrow we have the there are more session regarding to the cylinder specification, then about the H2 exhaust after treatment technology for hCNG and IC technologies, then H2 production and hCNG blending. There you can there you will get the knowledge about the hCNG blend, like how we blend the hydrogen and the CNG. They are and then we have the overall the vehicle overall packaging and system integration. There you will get the idea about the system integration, uh, last year I can see like a lot of teams are facing difficulties in the integration part. So there you can get the idea about the integration and its component. So you will get the more clarity. And then we have the session of the regulatory framework and safety requirements for hCNG vehicle, where you can like that's not the oriented to hBAJA, but other than the hCNG knowledge, where you get the knowledge about the safety requirements and the standards which followed by the Indian government to for the hCNG vehicles. And the last session we have that is virtual round, where you get the idea about the virtual round, like which points you have to cover in the virtual round and how you have to prepare for the virtual round. So we have covered all the session for today. So we are wrapping the day one of the hCNG BAJA today workshop. So I hope like today we will you will attend the session for tomorrow also. Okay. Yeah. Okay, so thank you team for joining with us today. So from tomorrow we have the first session at 10 a.m. So I accept from 10 a.m. all like you will be joining on the time on time. Thank you, Sandeep. Like you can close the session.
Yeah, sure. Thank you everyone for joining for today's workshop. See you all tomorrow. Have a great day.